moet ze alle twee hebben.
Oh, but for... Okay. This doesn't need to be recorded, and doesn't really matter.
Yes, indeed. I hate it.
You can never have too many mics.
Yeah, so, good morning. We're doing something new this year. I've never seen the deck that Toshana's prepared, so I have no clue what I'm going to talk about. Apparently this is CfgMgmtCamp. Who's here for YAML camp? That's tomorrow. So we have 3 days of conference prepared again. There's obviously going to be a bunch of schedule changes because people didn't survive FOSDEM or didn't get here or whatever. But is that on the next slide, schedule? No? What's on the next slide?
You'll see in a minute. Well, we need to make announcements about workshops first. So
I was about to talk about schedule and
okay.
Yeah, cool.
You do it. So yeah, we have 3 days, as you know, but our third day, Wednesday, which is the workshop day, has exploded. So please, if you registered for a workshop, make sure you select a workshop that you want to go to. That is not because we want to know where you're going, but we need to do sizing. So it's not the meaning that if someone has 100 people in the registered, that they actually show up, because we give you a hall of 100 people. If there's only 2 people, we can give you a smaller room. And we have an announcement that the SA Linux one has been cancelled. We just got the message this morning. We haven't updated it on the registration, but on the schedule it's already there. During the morning I will disable it in the schedule also. So
You do not disable SA Linux?
No, I don't disable SA Linux, only the workshop. Oh yes, Wi-Fi.
Yeah, we probably can replace the whole workshop with one slide, set and forth 0. If you're not already on the Wi-Fi, this is the Wi-Fi. If you're here for the 2nd year, it's the same Wi-Fi as last year. So that brings me to a question. For who is this the first year? Whoa. Who's been coming here since the very first year? That's a fun mix. Okay, no, Stefan, we're not going to list all the conferences you should have been to, and not the ones you should be organizing. But nice attempt, because, yeah. Yeah, that's for you.
Yeah, so we have socials, so #CfgMgmtCamp. We don't have vowels because they were expensive. We were able to buy one. The second one is a matrix space. We also have the URL chat.configmanagementcamp.org if you just want to see the general and attendee. And then we have a Mastodon instance, and we also have an Android app since this morning. Which is, yeah, it got approved this morning. I've been waiting like a week for a Google approval. So it's Event Plan, an open source application that we basically put the logos of Config Management Camp, linked it to the schedule, so that should be working. And it's also, like I said, only for Android for now. And then the schedule. So we have 2 talks before the break. Then we have another another talk, and then we have a whole bunch of Ignites. I think we had 1 Ignite cancellation, so if you want to do an Ignite, there's still a slot available.
You know what an Ignite is?
It's a 5 minutes presentation, not very long, not very difficult. Slides just auto-forward. And then our sponsors. So Betadots, it's a German consultancy company, primarily doing Puppet and now most probably other things also. They have a booth there. Please go visit them. We have Ansible, Flux, Pulumi, Isinga, AT Computing System Initiative, and Trilent. These are platinum sponsors. We have Red Hat, Double Verify, QLabs, Kangaroot, and Overlook Infrastructure. These ones also have a booth. For the booth, I'll come back to that later. We have SVA, who has swag at the entrance. And then we have Vox Populi, which is a bronze sponsor, which is the open source Puppet modules. Then we have a social event. So this evening at 6 o'clock, you go out from this building and you walk towards the street. You take care when you cross the street, and opposite is directly the zone. And then we have free drinks. To get free drinks, you need a wristband. For those people that have been here before, you know how this works. You go to the sponsors, they give you a wristband. If you don't have a wristband, you find one of us organizers and you'll get one also. But we're trying to encourage you to go and talk to those sponsors so that they keep on sponsoring. And that's it, unless we have any other announcements. No. Like I said, for the schedule, please make sure that you update your registration for the workshop. Again, this is for us to be able to do sizing. Tomorrow afternoon, we will be doing the sizing so that on Wednesday, you actually get a room that you will fit in. So please make sure that you update that. I will update the changes to the registration page shortly. And Michael, who will be talking about predictable workloads we didn't care about. Yeah, I'll take that in a minute. You need both of them.
I need both of them.
Yeah, that's for the stream. That one you can put. And this one minute.
Oh, I can hold it. I'd rather hold it.
Okay.
I like to move around when I talk.
Okay.
There are definitely chairs and stuff and places to sit if you squeeze, if you believe.
Are you wired?
I have this, I have this. I don't have that. So. Like, that's the same cable? All right. Seems important.
The light's still on, huh?
Yeah.
Red one, yeah. Okay. If the battery fails, then I will come running down and
All right.
because
So if I see you running at me,
Yeah,
it's not a crime. All right.
it's difficult to see inside those things.
Yeah.
Yeah, different versions. First, we need to get video working. Okay. Ja, een ander HDMI-kabel?
Dat de man.
Ja. Ah ja. You see? Waarom niet werkt? Nothing working.
Everyone, if there's a seat next to you, please move in. So there's a few extra spots for everyone else. So just please do the process compression. Defrag, whatever you want to call it. Does anyone have a spot next to them?
Can you go to the Apple setting
Thank
thingy?
you.
I mean, it doesn't see it at all.
Nee. Ah, okay. We'll switch it out. Well,
This is going to be a short talk.
no, see that.
probably have an adapter. Let me try. We'll just try that and see if that does anything.
So while we wait for Michael to set up, people sitting on site, please find your own seat, please find separate, and please be seated on a seat.
If it's really more crowded, the beacon has a live stream. And Mark is really lonely here right now.
I don't know what's going on here at all.
Can you try maybe this?
I can absolutely try that.
When you put it in, let me know.
All right. Why does this not work at all?
Well, it's telling you to choose something, so. Yeah, with the USB-C.
Yeah, we've been trying things, but I still don't know what I'm doing now because apparently. Is it? No. Like usually there's a thing like extend to this thing, and it doesn't show that there's a display. That's the part that I'm very confused about. Let me try.
I don't know how Macs work, sorry.
I barely know how Macs work clearly, so.
I can do this on a Linux machine, that's about it. I wouldn't even know how to do this on a
It
Windows
says
machine.
mirror or extend.
Sorry?
Never. I got it. I got it. I got it. I got it. All right. Sorry, I was used to having to modify an xrnr.conf and then having to rebuild x11, and this was just too simple. I didn't know what I was doing. So, yeah. Anyway, I still have 5 seconds until it's actually time to start anyway, so everything's fine. So, welcome to Config Management Camp. My name is Mike Stonke. I work at Phlox. We are a sponsor. I did not pay for this talk by being part of Phlox. I've actually been in the configuration management space for a very long time and care deeply about it, which is why I keep working at companies that are adjacently related to it. So I just wanted to put that out there. I'm the VP of stuff, and stuff is changing ever presently. So that's why I decided that titling it was just unimportant, and I do stuff for Phlox. So over my career, I spent time at a few different places, but from big enterprise to smaller shops that are more startup-y, and did all sorts of stuff along the way. And most of that is just kind of to think about the arc of my career and what I had done and why I had done it. And as I was reflecting and looking at things, I was looking at these workloads and thinking, wow, we had this whole industry where we defined everything as, if I can figure out how it's supposed to look, I can make it look that way. And that was basically the goal of configuration management. And it didn't matter if you were starting with CfgMgm or ISConf, where you went up to Puppet or Chef or Ansible, or you were using modern tools that were YAML-based and you liked it for some reason, whatever. There was just a lot. You could define desired state. But then you got to this purpose where desired state was a myth. And I first started feeling that desired state was a myth when I worked at Caterpillar, because they were always talking about how good the future was going to be, but I realized we never achieved the future because you never actually retire everything or actually complete every project. You get it like 80%, you go have a stellar, move on to the next project. And so basically desired state was also a myth. And I then started applying that to computers, where it was like, well, I've defined most of my state, but there's still parts that are left over that we haven't defined. And it's probably okay because it's probably not changing, but I haven't really said this is how it's supposed to be. And so then you start trying to apply science. I have these workloads, I have these deterministic things that I'm trying to do, And so you start with science. And so we built everything around fixed point. Basically, if the manifest is correct, this system will end up being correct. And the value of manifest, you can insert whatever it's called in your tool of choice. But your system definition, if it's correct, you're all good. So the problem is that a lot of that science under all of this actually is math. And so when you start looking at something like this, I have a function, and if I run the function again, it still works. If I run it again and again and again and again, okay, what's that? That's idempotency, right? If I have this formula, I can do it in this order, I can do it in that order, and it's going to end up in the right state either way, right? And that's commutative, I think is how you actually pronounce that, but I always call it the communicative property because apparently I'm bad at pronouncing things for most of my life. And then you get to this one, which is kind of my favorite, which is just you do a function and you get an output. That's pretty normal, pretty understandable. But the whole thing this is trying to tell you is there's nothing else in the world that matters for y other than that function. And that's really hermetically sealed things. I don't know how to actually say this word either. This is really fun. But basically, the idea is that without side effects, you have something pure. You have something very nice. And so when you try and build something, I don't care if you can't, like, maybe you can't talk to the network during a build, or you can't talk to the extra file system during a build, or there isn't, electromagnetic interference from a printer causing you to have bits flip for parity. Then we get into convergence. We had eventual consistency, which was super fun. We'll get there, I promise. Declarative. We had declarative technologies. We have dry run and planning. Because of that declarative mode, because you're kind of saying, I know what the system state should be, you can actually do things with a plan, which was really great. And so ultimately, we've always been at war with entropy. That was really what this entire thing was. We had a system that we've defined. We're trying to fight entropy, and we move from there. Some people got super obsessed with this. And then this field developed that was called chaos engineering. And to me, it was kind of weird, simply because I was very good at breaking systems. I didn't need the help of other computers to do that. But it just kind of happened. And so we had these known inputs, we had the system, we had known outputs. And then we had users. And if you're like me, users and chaos are roughly equivalent when you have users at a large enough volume. And so basically, a sufficiently large enough selection of users is indistinguishable from chaos engineering. And for those that don't get the little thing in the corner, it's these two people that worked at a convenience store, and they're in the middle of saying, this job would be great if it wasn't for the fucking customers. And it's like, these servers, they would stay online forever if they didn't have applications and users. So, but the problem is we do. And so what did we do after that? Well, recently we decided to take the most difficult part of computers, we replicated it, we've made it super easy to use at levels never imaginable. And what's the most difficult part of computers? Well, the people. And then we started making these processes that we anthropomorphize as people, which is just weird. And then you start to get into other problems where, okay, I have a problem, I've run a workload, it behaves like a person, which is, again, weird. And now I need to debug what's going on. Okay, so I'm not clever enough to do this, and this is from the 70s with Kernighan talking about debugging software. And then you get this immortal SKCD saying, like, the first step in toward troubleshooting anything is that you have to reproduce. And if you can't reproduce the bug, how do you actually figure out if it's broken or if it's real or whatever? I'll let you read that for a second if you're not familiar with this one. So you go from this deterministic to probabilistic outcomes. And determinism, okay, if I flip over one of those dominoes, I kind of know what's going to happen to the rest. Over here, I just start rolling things, and I'm playing probabilities. I'm playing bets. And don't look at the dice too closely. There are too many fours on one of them. It's really weird. But now we're in this modern world where probabilistic workloads mean that I do not have all of these certainties that I'm guaranteed, or that I'm used to being guaranteed. I run something, stuff happens, and maybe it's okay, and maybe it's not. And if I run it again, it's going to look different. This breaks my brain. I've been thinking about this for like 6 months straight. It still breaks my brain all the time. But now, so we have to think in bets and probabilities and distribution. And so literally, I went and found my discrete math textbook from college. It was one of them that I kept because I actually really liked discrete math. and started thinking about, okay, how do I apply any of this to what I'm currently doing? And what I learned was my love for discrete math and my current understanding of discrete math have not stayed congruent over time. So, but I'm going to take you on a little journey of an example of things that I did understand completely well. And that was, okay, so this is the Flocks website where you can download Flocks. There's no version here in this little like download file, so you have no idea what you're getting when you download. And we got a piece of feedback from a user that said, hey, I'd like to know what version I'm downloading. And I was like, that is a completely valid request. I would like to help with that. And so clearly, I turned to an LLM and say, hey, in the downloading area, there's not a version. It'd be cool if there was. Can you do that? And some LLM says, sure, and it gives me this little thing that says Flocks version 183. I don't love it, but whatever. This is what I end up with, which I do like because it's much more stylized the way the rest of the website works and stuff like that. So that's what I ended up with. But one thing I realized during this journey is that your assessment of simple and complex does not necessarily match your tools or your LLM's abilities or whatever. Because I happened to be at a bar when I was working on that version number change because the person that gave me the feedback was sitting next to me at the bar saying, hey, it'd be cool if I knew what version this was. Okay, I work on that. And I was doing another project that was more a thing that we were just pairing on and having fun with. And so I had two projects. I was trying to add a version number to a website, and I had a 20-year-old application written in Perl that had been running in production for 20 years that I was like, I'm going to go see if I can convert this to Go for funsies. So the version badge took more than 6 hours. I tried it with 3 different LLMs, 3 different tools from the ground up, and what I learned was React was a mistake. The 20-year-old Perl application, literally one-shotted it with Gemini, and it ran with the happy path 100% correct. Every single test passed in the happy path. The error handling was a little bit rough, but honestly, I wrote up like 3 tickets and they fixed it, and it was fine. So the thing that I thought was going to be really complex was converting all this Perl code into Go. Wasn't hard at all. Adding a version string, which I thought was going to be literally add like, I don't know, an image URI or something to a page, was hours and hours of iteration. By the way, CORS is just the worst. I know y'all think front-end people are like very different and like not skilled the same way that the back-end people are. Trust me, front-end is so much worse than what we have it. And so we get back to the science though, where because of that, I was like, okay, I tried to add a version badge and I did it through different LLMs and I got different outputs in different colors and different sizes and different shapes with different levels of technical correctness and all of that. And I was just like, okay, how would I test that at all? I got nothing. No. So I was like, okay, we're going to do science. So we have to isolate and control for the variables. The entire scientific method is you have this whole thing you're trying to prove or disprove a hypothesis, and you want to mess with each variable individually and not all of them at once because then you can prove that nothing correlated to anything else. So basically, I want to make the set of things that I know as large as possible. And so the set of things that I know very well, based on the disciplines here today, are idempotency, commutativity, and hermeticity, hermetically sealed things. And so once I know those things and I have that certainty, I need to find this like anchor in all of this because I'm in this probabilistic world where determinism is no longer the thing that matters for every single workload. My brain still doesn't quite comprehend it, but I'm going to keep talking about it. So I need determinism. And so I have this shift from static to agentic. By the way, every time I see the phrase agentic AI, I just get, I don't know, a little bit non-happy. I don't know what the right phrase is. It feels like you just say agentic or AI, but agentic AI feels very redundant to me right now. But I need the environment to be reproducible because the behavior isn't. And so what I need is the workload, where the workload's happening, to be as concrete and foundational as possible. And then I need to have this boundary enforcement. So basically, when you have an it depends thing, you now have to start thinking about operationalizing it depends into your thinking. And this is kind of done with boundaries where you have, okay, here's the bottom end of what is okay, here's the top end of what is okay, and if we are anywhere in the middle of that, we are happy with how things are turning out. Which like, conceptually sounds really simple. It does not sound really simple to like put on a dashboard and things like that. So, but you basically go to, is this behavior within bounds? And as I started thinking about that and going back to my earlier theory that users are chaos, and I was like, well, who's dealt with this chaos before? And it was SRE. And I mean like real SRE, not an ops team that was renamed SRE. And those are two different things. So, but if you had real SRE, where you had business understanding, where you actually had SLOs, where you actually had things that rolled up to user management and error rates and all of that, you kind of had a lot of this already. And so if I'm making the set of things I know is possible, which is not, make the set of things you know as large as possible, but it can't be that large because the users and the chaos is actually what's driving most of the problems. So we move from this state enforcement to boundary enforcement. We'll get back to the SRE thing in just a moment, by the way. And the other thing is, a lot of people think sandboxing is the answer for how you solve a lot of these problems. This is a completely orthogonal discussion to understanding the probabilistic workload. However, sandboxing is also not the total solution. It's a small feature in the overall output of everything going on. So we have to prove that Y stays within bounds. Well, this is a lot like an SLO from an SRE team where you're saying, okay, my error rate or my P90s or whatever is going on is at this level, it's in a threshold, it's got a boundary that it can't cross. Okay, now we're starting to get something that I think we can relate to a little more. But then you get into some of this math more of like how you would display this into, here's how I know it's good, here's how it's bad. And for years we wanted everything to be equivalent and work. And now we have to use like new symbols and I have to remember the Greek names of these things and it doesn't go very well for that part either. But you want to know set theory. Is my outcome within the set of acceptable things? So if I have a probabilistic workload, is it a member of the sample set of success? That's what that looks like. And let me tell you something, I got to play with LaTeX and put it in Keynote. It was cool. And the other way you can kind of look at this is, okay, the thing I did versus the thing I wanted, the absolute value of that, is it greater than the set of the probabilities that I wanted to be in? You can call that an error budget. But basically, we're in a world now where if something failed, you don't know if it's because of something you did or something that something else did. And that's really hard to figure out. And that's why you want to isolate that to be the smallest amount of side effects that can have that input. But you also might just be at the tail end of a distribution if that one thing looks very odd. So if I would go run that version badge request, let's say I ran it 50 times, and one of them just came out with like a text output that was just, I don't know, I'm just going to screenshot, an 80-character terminal in green screen, and we're going to put that in the version number. Is that acceptable? Is it not? Like maybe it's at the tail end of acceptable. It's like, well, the version number's on the screen. And so you can kind of get to this, what you hope is that you have a bell curve for acceptable outcomes, and most of the time you're kind of in the center and you can work around that. But just like with rolling dice, sometimes you roll snake eyes. It's not that likely, but it's not like unheard of. And it's still fine. It's still legal on a if you're playing with 2 dice. So you have to think about things kind of that way. And then you end up with workload evaluation criteria, which is a fancy way of saying, I know if it worked. And so the process of running is the port open was deterministic, but now we have this like confidence interval. And again, you can map this back to an SRE concept of basically SLO violations, SLO, things like that. So it's very much take what you learned from your experience, but think more about this from a probabilistic standpoint. Think more about, I understand these workloads. And statistical alarms, like you don't want it to be the thing that's telling you about it. You want to know of the probabilities of the error curve is immensely. So if you were getting distributions where they're all range for days and all of a sudden it's like everything is at the 9th percentile all the time. Okay, changed underneath or something changed, or the user behavior changed, but something is off there because you're no longer distribution. And so down to now, chaos is a property that but the real thing is here that chaos has been a thing that because we always had you.
Can just
Continue. Our monitoring or observability solutions have been doing. They might have been doing it in the user space, but not so much in the infrastructure space. A lot of these tools had things to give you P99s or average or distribution changes, and I just don't think that we had invested in that lower level, like below the application layer, too often. It wasn't never, but it wasn't as often. And so shifting to unit testing to statistical testing, it's like Now my QA department needs a minor in statistics was something that I heard, which is fascinating, both that they had a QA department and that they thought you needed a minor in statistics, but it's okay. And so if you run something and it didn't run properly, your boundary was actually the thing that was violated. It doesn't necessarily mean that the thing didn't happen the way it was supposed to happen, or it didn't happen. It's just, okay, I need to run it again, or I need to do it more often, or whatever. And so basically, because of this change with agentic workloads being, I don't know how they're all going to behave, you have to know what right is to some degree, which is essentially the role of QA. But to know what right is, you have to know what it was supposed to do. And to know what it was supposed to do is essentially the role of a product manager. And so we're in the middle trying to figure out, I have this product process, I have an engineering thing happening, I have a QA process, and you have to put them all together and say, I have this probabilistic workload. It's a little bit daunting. It's a little bit scary. I don't know how many of your workloads today are probabilistic, but that's increasing all the time. And what I found is that I can't debug things very well in probabilistic with like mutable things underneath. And I used to think that mutability was a thing you argued about for academic purposes. It was like, Rust saying, we don't do mutable variables by default, or Clojure being like, it's never mutable, or whatever. And I was just like, this seems super academic and unimportant. And then I got into a lot of this stuff. And then I got into Nix, which definitely also changed the way that I felt about mutability. But basically, you need this environment that can't change so that you can reproduce these workloads or run them more often so that you get sample sets that are valid. If I can run this 100 times and I know the only thing that's changed is the workload and not the environment underneath it or the network traffic or the user patterns or whatever, now I can actually have much better analysis. And so how do you get those environments to be constant? I don't know. Anyway, so basically the new CI/CD pipeline, though, is you want to provision this hermetic environment. You want to run the probabilistic workload n times and then measure the probability of success. And that does feel pretty different. And there are tools that'll help you do this, and there's the way dashboards that do all this now and stuff like that, but this is just the fundamental, I guess, underlayings of that. You no longer ship because the build passed. You ship because your success distribution is approximately where you'd like it, or within bounds. And you want to have an environmental success score that's valid. So basically, I've done the workload, I put it onto a immutable state, I've run it n times, I'm confident in the interval, I scored it, I know it's within bounds, now I'm going to ship. Or now I'm going to move to the next phase of whatever needs to happen there. So I guess I would say for the summary, you would like to basically pin the substrate, have foundational technology that really locks your environments. And you can achieve this with a lot of different tools. I don't mean to say that this is only working with Flocks, but man, it's a good idea. But you could also use, you can use containers to do a lot of this stuff. Locking a container to be completely immutable is a little bit difficult. You can do it from an image perspective as long as that container in that image is what you use forever. But if you ever want to update that image, now you have a different issue. It's not terrible, but it's just more difficult. You really want to look at the shape of things. And so basically, alert on your shifts of probability, not just pass-fail. It's more about the slope of the line than it is the line itself. And this baseline for normal randomness is okay, my distribution normally is this wide versus this wide. And those are just new things to think about, at least from my brain. And so basically, to wrap this up, as I was thinking about it, was determinism was our childhood. Determinism is our childhood, and that was what we had for the last 15, 20 years of this configuration management space stuff going on. It was probably longer than that. I joined it 20 years ago, so that's what I'll say. I can't speak for before that. Probability is where we're headed, probabilistic workloads, and a lot of that is you can map in concepts that come from managing humans onto computers, which again is a weird thing to pull from, but it is working out pretty well. And then we have to have these strong foundations that are side effect free to run these probabilistic workloads so that we can get accurate measurements to see if they work or not. So taking all that into account, the amount of code being generated by LLMs and AI tools and such like that is large. And there's still a high degree of skepticism for it. That's fine, it's healthy. But there's also people that are wildly successful with it. That's fine. Somebody should be. We're spending $1 trillion on it. But basically, we have this unknown quality now. we don't really know if the code that we're seeing for most workloads is good. And if you don't allow AI, that's great. Do you buy software? Cool, because that might be written by AI, so something in there is probably written by AI regardless of what you're doing. And so you need to treat basically this stuff as hostile, because you don't know. And honestly, if you treat everything as hostile, it's not necessarily a bad foundation to start from regardless. Users are terrible. So you have to basically have these control points to develop. And if I was going to leave you with something to think about, it's if you've been building this world of configuration management and operational technologies for a long time, developers were kingmakers for the last 15 years. Whatever developers wanted, they basically got in our industry, in our verticals. In most cases, unless you were super highly regulated where you could just tell developers to pound sand and say you have to do it this way. It's not super common. But now that you have this hostile code, you need these control points and you need these developed. And so this is our time as operators to actually be back in the world and be relevant for everything. And I'm really excited about that. But it does mean we have to evolve and we have to understand these modern workloads. So in closing, wow, statistics is weird, and now I need to know that to do my work. But if I'm good at it, I have job security like I've never had before because these workloads are nuts. Okay. So that's how I'm going to wrap. Basically, I want you to think about kind of the world has changed in that we strived for determinism for a long, long time, and then we went to probabilities, and we're all learning about that again if we haven't thought about it since university or ever. So yeah, there's the QR code for this deck. We do have a Flux workshop on Wednesday, so if you'd like to check out more about Nix or Flux, we'll be there. And thank you very much.
Don't go away, don't go away.
Okay.
Thank you very much for the talk. We have a little bit of time for questions while our next speaker gets set up. So if you'd like to ask Michael some questions, just raise your hand.
And just repeat the questions, if you don't mind.
Nobody has
Who's
questions.
got a question?
Nobody has questions.
The other thing you can do if you're a bit shy, you can post your questions on Mastodon, and we can debate all these topics. I'm about to post something myself. Yeah, Adam, go ahead, just scream it out. And
Michael, is it that F changed or X changed? Because it sounds like in your talk you're saying that the change is that F is probabilistic. And I think that that's wrong. It's X that's probabilistic. The inputs are what's random, not the function. Most of the system remains deterministic.
Yeah, so I think Adam is basically saying, is the function that changed or the thing you're operating the function upon changing? Yeah, the inputs. And I think that's a totally valid question. And now that I'm thinking about it, I like your answer better than mine. So no, it's fine. The workloads are not deterministic. Like I actually don't think a lot of the workloads are deterministic. Like the way they operate is, but the payload through it isn't. And so I guess it depends on where you're measuring as to what the function is, like what's the unit of function, because is the workload itself a function that you can't determine the output of, or is it the superset of everything that's building up the workload? So does that make sense, or am I just rambling?
I think you're maybe rambling.
He said, I think you might be rambling, but I love it. Okay. I'll take that. So, yeah.
So we know that the substrate is most likely not going to be deterministic because as we know the meme is we test in production, right?
Mm-hmm.
So what do you do in those cases where you can guarantee that the substrate is not going to be deterministic?
Okay, so he said, we know that the substrate isn't deterministic because that's why we end up testing in production, which is fair. And so what do you do then? And my answer is cry. No, I think you have to kind of figure out where your risk tolerance is for certain areas. In some cases, you might say, I want a very deterministic foundation. In other cases, what's your cost of being wrong? Like if your cost of being wrong is super low and you can ship again in 3 minutes, it's not that big a deal. And so it might just depend on what right and wrong looks like or what your risk tolerance is. But I will say that having used a lot more immutable infrastructure and foundational stuff, I've tried to make that deterministic base as large as I can. But even some of the workloads that are on it are crazy at this point. So, yeah.
Yeah, try.
One more? Okay.
Yeah, just perhaps a silly question. How do you actually emulate chaos
Check.
in a
Han?
pipeline?
Good.
So the question is, how do you emulate chaos in a pipeline? There's a few different ways to do it. One is you actually just roll it out. No, I am dead serious. Like when I was head of engineering at Circle CI, we would put out a change, put it to 0.5% of traffic or 0.025% of traffic or whatever, and you'd start to get signal really quickly on what the error rates were on that. And if the error rates were below threshold, you'd continue rolling out to the rest of the fleet. And part of that was, people would be like, well, how do you not test that ahead of time? Okay, I don't know. Then people would be like, how do you not test that ahead of time? It's like, we can't build a test infrastructure that can replicate this amount of traffic, this amount of service conversation going on, and so you have to just isolate small volumes of it. And we could route certain customers to make sure they were never on the canary routes and stuff like that. We had a lot of control points like that, and that's what I'm saying, like a lot of this stuff for probabilistic workloads, if you go borrow from SRE, you actually will get a lot of the distance covered that they would like to get. So, yeah.
Any more questions? We have
All right.
some time, so don't be shy. He'll take hard questions. He gets paid the same if it's an easy or hard question, so don't be shy.
We could sing songs if you want.
Yeah, over there.
If AI bubble will burst and all of this will die, does it make any future?
I think his question was, when the AI bubble bursts and dies, will there be a future? Was that what you asked? Okay. Like, I have a couple existential thoughts on this one. No, I don't think probabilistic workloads are going to completely go away. I mean, they never really have. You've always had users and stuff going on. But you also have, how do you measure the outcomes of these? Like, okay, so maybe AI bursts in some way. Do you think it's going to go to zero? I don't. Most technology doesn't. Even if it blows up, you learn from it and you move on and you build upon it. And a modern LLM may be great for 3 to 5 years. Who knows? Maybe the next thing is generative AI replaces all of this, I don't know. Somewhere we get to the point where Skynet exists or something, and then you still have probabilistic stuff going on. Maybe we have to measure it or defend ourselves, or whatever. So.
Just a quick organizational note. If you do want a seat, and we're basically at capacity here, there's also the overflow room just in the main building where you came in and had breakfast. So you can sit there, it's cool, and there'll be a live stream of this room as well if you really don't want to be on the stairs. We've got at least time for one more question. In the back, someone on the stairs. Chris, I think Chris has a question on the back. If not, then let's give one round of applause for Michael.
Thanks.
So as it turns out, it's not entirely optional. So if you're on the stairs, please try and go to the overflow. Thank you. If you want to run, I can delay his talk by like 1 minute, but you got to really boot it because you don't want to miss Richard's talk. Give him a minute.
James,
Yeah.
can you say where the overflow room is?
I did. Just a reminder, the overflow in the main room where we had the breakfast, in the back, there's that room there, the big conference hall. It's called Econ. E.con. Where'd Michael's mic go? Oh, there you go. There's both. So you can have your own chair. This is yours. And then I'll introduce you and then you...
Okay, is this on?
It's on.
It's on. Check, check.
Little timer warning things.
Might be helpful, but
Hold up little signs.
yeah, I didn't really time this. I didn't really attempt to time this.
It's not the end of the world if you go a little over. We have a break right after.
Mhm.
If you want,
And we're sort of starting earlier.
We'll start you like 4 minutes early. So you'll have an extra 5 minutes if you want.
Yeah. Yeah, and I wasn't aware whether taking questions are customary.
Yeah.
That's fine, although I'm not sure. I can take questions on any topic.
Don't
If the battery fails, I will come down
Oh,
and
okay.
help you.
don't say anything too embarrassing because you're live now.
Yeah.
Better? Start in 2 minutes, get those overflow people a chance to get in. And we'll start 5 minutes early. Well, just a longer break then. He's supposed to start at 10:20.
No, just let him start now.
Yeah.
And then we will do a longer break, or if he has more questions, then so much better. But
So keeping in mind that everyone can hear us, I was looking it up. I think I've actually known you for 13 years. Met you 13 years ago. If you can believe it.
It's possible.
Jeez.
all right, everyone, have a seat. We're gonna get started. So it's really my great pleasure to introduce Richard Fontana. I was trying to do the math, but I had the fortune of meeting him I think around 13 years ago, if I didn't screw the math up. I was a young kind of junior Red Hat employee that I had just gotten hired, and I'd known about Richard as kind of being an authority on everything licensing and whatnot. So I randomly knocked on his door when I was in the office in Red Hat. And he was a super friendly, super nice guy, and I've basically had the pleasure of knowing him since. If you don't know, he's basically been Red Hat's key open source licensing lawyer. He is an actual real lawyer for forever. He's consulted and advised countless open source projects and developers. And actually recently, as you know, Red Hat got purchased by IBM. The legal department, as I understand it, at Red Hat got actually consumed?
Merged, integrated, integrated.
By IBM. So anyways, I'm very happy to have him today as our keynote speaker, so please give him a giant round of applause.
Thank you. Thanks, James, for that very nice introduction. Yeah, one question I was wondering was whether Joe Brockmeyer would be here. Does this mean you might write an article about this?
Just might, yeah.
So hopefully it's not going to be a very interesting talk, so it won't be worth writing about. Yeah, and you're giving a talk here tomorrow, right? So this is not a talk about config management, if that wasn't already obvious. I don't have any significant technical experience in config management that I'm aware of. I have in my day job provided legal advice, legal support to people working on some of the projects that people are talking about here, like Ansible and particularly Ansible. Once in a while. I noticed there's at least one session on Puppet. There's one on Foreman. So I have that kind of experience of supporting the people who are creating that software. But this is more of this is a talk about open source. So if you work on open source, some of this hopefully will resonate with you. Let's see. So, oh yeah, James mentioned that I've worked at Red Hat, and now I am officially an IBM, like in a direct sense, an IBM employee. There are a lot of Red Hatters here, I'm aware. Like, are there any IBMers, like non-Red Hat IBMers? Just curious.
They are, they're just shy.
Fascinating. Out of morbid curiosity, is there anyone here from HashiCorp? Not one person.
Also hide
Yeah, you don't have to hide. Yeah, so I still identify as a Red Hatter. I don't really identify, for what it's worth. But this talk is not a Red Hat talk. This is not an IBM talk. I am on vacation. This is like, seriously, I wanted to go to Ghent. Yeah, so this is my first time here. So that's very important. It's possible that in the course of giving this talk, I may briefly put on my red hat or not, or sort of draw upon some experience. I mean, the talk reflects my experiences at Red Hat mostly, but that's only because I've been working there for a long time. All right, so yeah, this is kind of an unusual talk, I think, because it's a little bit half-baked, but maybe in the future I'll give a better version of it than I'm likely to give here. So one thing that, the way I look at open source may be a little bit different from the way most of you look at open source. I tend to be fascinated by the problems I see in open source. I'm struck by how there seem to be these periodic crises and disagreements and arguments. And one reason, obviously some of those are about technical stuff that you will all be familiar with. But some of them are about what, for lack of a better word, a better term I will say is legal stuff. Or stuff that is sort of interesting to lawyers who sort of specialize in this kind of space. And I used to, the people I work with at Red Hat, Red Hat lawyers who support Red Hat, I should say now, they're sort of a little bit more distant from open source than I am, and they often ask me okay, what's the latest controversy in open source? So there's even they have this awareness that there is this kind of recurring tendency for people to have arguments over stuff, and for there to be concerns about things sort of relating to legal stuff that are going wrong. So I sometimes think of these as crises. I'm going to refer to them as flashpoints because I think crises is a little bit ridiculous. But I kind of there are arguments and debates, and you probably are aware of some of them, even if you have not been in open source for a very long time. So it occurs to me that these periodic arguments and crises and flashpoints, whatever you want to call them, they're not totally random. They're not. Each one is not totally new. They seem to have some underlying features in common. There's a pattern. There are some patterns, or at least that's what I would try to hypothesize. And in trying to think about this, I think that the thing that varies over time is what I'm going to call infrastructure, for lack of a better term. And when I say infrastructure, I couldn't come up with a better word for this. But I don't mean servers and networks and stuff like that, although I guess I could include that. But I kind of just mean the current state of play that software is situated in, from a technical perspective, business economic perspective, cultural, social perspective, like everything that is sort of relevant that is going on in the current situation that software exists in. And if that is sort of confusing, that's understandable, but the concept might make a little more sense as I go along here. So there's this varying infrastructure, and that's actually the varying feature is the common thread. So when I think about this concept I'm calling infrastructure, again for lack of a better term, the way that participants in ecosystems around software sort of exercise power and freedom, and whether from a kind of legal standpoint or business standpoint or whatever, social standpoint, think about the governance of open source projects. The infrastructure, the features of the infrastructure at any one time are going to affect like whether you have freedom to do stuff or you don't have freedom to do stuff, and whether some people have more power than others at any sort of given moment. Just going to take some water here. And a key, I think I haven't said this before, but in a way it's kind of obvious, an obvious point. So the underlying like legal foundations, James mentioned the term licensing. He said I forget how he put it, but I do work on licensing, or I'm knowledgeable about licensing. There is a tendency to kind of think of lawyers who work in this space as focusing on licensing. In fact, many of them do, but that's actually, in a sense, like one of the problems that I've observed. So the licenses in open source are built on these normative definitions, and you probably, hopefully, know about like the 4 freedoms that the Free Software Foundation maintains. So free software being embodying the freedom to run, study, modify, and share. There are other formulations of that. And then the other major normative definition for open source doesn't use the word freedom, I don't think, but it's sort of focused on the same kind of concept in a more complex way. It's the Open Source Initiative's 10-part open source definition. And the observation is that these normative definitions that are kind of like think of them as like a constitutional foundation for open source. I wouldn't even really say the legal part of open source, it's sort of open source in general, that these are anchored to an earlier technological world, the world of the 1980s and 1990s. It's kind of obvious because that's where these things actually came from. They were formulated in the late 1990s, and they have roots. Some of them have, the FSF's 4 freedoms has, well, it used to be 3 freedoms, I think, back in the 1980s. So it goes back to the mid-1980s. The open source definition is basically a modification or rebranding of the Debian free software guidelines, which is still sort of a constitutional basis for how Debian decides what is suitable to be packaged in Debian. So this is kind of old stuff. And the observation that I'm trying to make here is that this concept of infrastructure, so the state of play in software obviously keeps on evolving, and there are these, each time it evolves, these new tensions and power dynamics pop up. But the definitions that are, underlie our understanding of open source and free software stay the same. They haven't, for the most part, haven't been revised, and in fact, no one is really interested in. Well, that's not quite true, but the gatekeepers, and I think I've been one of these gatekeepers in the past. The gatekeepers don't want to revise these definitions. They very much support these definitions. So in a sense, it's open source is a conservative domain because it is tied to these old definitions that don't get modified as conditions change in technology and the economy and so forth. And so one of the features of open source that you see occurring when these arguments come up over stuff is that a lot of times people, not all the time, but a lot of times people think you can fix new problems by, perhaps coming up with a new license that resembles the old licenses. Or, there are some people so I'm going to contradict something I just said, that there is a small group of people who would argue that the normative definition for open source should change, but they kind of are still basing their understanding of the need for those normative definitions on the old established system. And so people sort of naturally reach for legal fixes when things go wrong. And sometimes that often doesn't really work well. And sometimes that actually creates new problems. So this concept of control points or leverage points. So infrastructure changes over time, and when infrastructure changes, new opportunities to exercise power occur. That's what I was saying before. These are control points, new control points. Sometimes when you try to fix them with legal stuff, things misfire in a sense, and the legal fixes create new problems and new control points, kind of ironically. So I also want to emphasize that when this concept of infrastructure, when infrastructure changes, conditions change, but so leverage points become available that might not have been available before. Opportunities to maybe make profit in a certain way or have a certain type of business model, or exercise power in a sort of project relationship or whatever. Those conditions change, but the actual the opportunities to exercise control appear that weren't present before. But humans are the ones who actually make the choices to exercise a particular means of leverage. So there's always, this is not like a deterministic concept that I'm kind of, articulating here. It is ultimately humans involved in open source are the ones with agency, obviously, and nothing is predetermined or inevitable. So I don't know if any of that made much sense, but I'll try I'll attempt to illustrate this a little bit by going through history and some of the history, or some of the interesting things that I think have happened in the history of open source. I'll sort of breeze through that, but hopefully some of it will clarify that kind of framework I was kind of trying to articulate before. Some of the interesting historical developments fit this kind of model better than others. So if you think about the origins of copyleft licensing, so copyleft, by copyleft, of course, I mean the GPL, the basic way the GPL is implemented. So the GPL was an aberration. The GPL is a very interesting license from a historical perspective, because before the GPL, originally you had software developers sharing code, and they were able to do this, of course, because for the longest time it was not clear that law could be used, legal constructs could be used effectively to prevent people from doing stuff with software at all. So software was inherently free. It was a commons. And then it became clear that copyright applied to software. That happened in the late 70s, basically. And suddenly, for that reason and some developments in the sort of business or economic sphere, and this is a kind of infrastructure shift of sort I'm talking about, it became possible to exert copyright over software, which made it possible for people to have restrictive licenses. And not only that, but thanks to at least one court case from the United States perspective, and I assume that there were parallel developments in other countries, it became established legally that object code was just as protectable with copyright as source code. It's not actually inherently obvious that should be the case, So you could protect object code, you could protect software in general through copyright, and what that means is you have the right to do things under copyright law that only the copyright holder can do. So if you're the copyright owner, you can stop people from making copies, basically, or distributing, or making modifications. That's the basics of copyright law. Once copyright applies to software, you can suddenly have, business models like Oracle or whatever. This is sort of like a kind of obvious but extreme case. Business models based on restrictive object code licensing. So the GPL is kind of a response to a leverage point that came to exist through these legal changes and economic changes at the same time. And the GPL, famously uses copyright law to create a different type of license that tries to keep software free. So the thing that happened was that, in particular, was that because software was copyrightable, you could take code that was already in the commons and create proprietary software based on it. And this actually happened. And some people were very happy about that, but many people were not. And many people in what became the free software community were not happy about it. And the GPL provided a legal mechanism for sort of combating that. So very interestingly, yeah, the GPL is a well-intended attempt to use a legal tool that became available to improve conditions that were sort of affected by changes in the law, right? And the GPL was very controversial in software developer communities. Some people, and this is true to this day, there's this schism, of course, between copyleft and permissive licenses, like the MIT license or whatever. Early ancestors of the MIT license, and of course the BSD license existed prior to the invention of the GPL, and that's in the mid-1980s. So when the GPL is invented, pretty soon what came to be called the dual licensing business model was invented to exploit it. So that, in a sense, the invention of copyleft became its own infrastructure shift, and it created a leverage point that some software developers decided to exploit. And this is really interesting because the GPL is designed to prevent software from being exploited through copyright. Dual licensing is designed to use the GPL to make proprietary software licensing of a certain sort effective again. Because dual licensing is when you have copyright control. For those of you who don't know, it's not talked about as much anymore for various reasons, but it's kind of a foundational development in the history of open source. So dual licensing is where you have control. You're the one copyright owner of a GPL license code base, and you provide a proprietary version for a fee. So you're combining GPL, you're using the GPL to have a proprietary software licensing-based business. And that is very controversial, but it took a long time for people to develop the vocabulary to explain why they were concerned about that. And part of it was the experience of how it was used in practice. So this is just an example of how one change leads to another change where the motivations are quite different. Instead of the motivations being to perpetuate the free software commons, you have people using the machinery of copyleft licensing to move, in a certain sense, move code out of the commons, even though in a formal sense it's still there. And there's nothing in the GPL that says this is wrong, or any other mainstream open source license or free software license. Very difficult to if you wanted to try to implement a license to affect that, it's very difficult to do so, and maybe not possible. I've had some arguments about that with people. So you have dual licensing, and And dual licensing is also important because it's the first example of a phenomenon that starts to repeat itself throughout the history of open source, this feature of asymmetry. When you have dual licensing, you have to have one copyright holder, and they have control. The way it works is only they have the right, because of copyright, only they have the right to license the software under a proprietary license. Anyone can exercise their freedoms under the GPL, but only one actor has the freedom to use proprietary licensing. So that's an asymmetry, and we see after that many other types of similar asymmetries in the history of open source. So to implement dual licensing, you need copyright assignment or contributor license agreements that give more power to the maintainer of the project, right? Because otherwise you're sharing the power to create proprietary versions. So it kind of legitimized asymmetry, and asymmetry starts to pop up in the 1990s and early 2000s to the present day. Asymmetry becomes a feature of many aspects of open source that relate to legal stuff, not just licensing. So contributor agreements is an example. And just like in general, it's not just licensing. So it becomes a feature of open source that entrepreneurs, businesses, companies come in and use open source as a way of making money, earning revenue, making revenue, in a way that is somehow divorced from the ideals that the software, open source software is founded on. So this idea that you have this system that is founded on these principles of sharing and so forth, but people make use of it precisely because it is, in a sense, because it is so permissive in the freedoms it gives people. People use it to introduce new forms of scarcity in some way or other. So the infrastructure shift that you probably, even if you think what I've been saying makes no sense, you probably have heard of what I'm going to anachronistically call the SaaS loophole. So once what's now called SaaS becomes a thing in, let's say the early 2000s, it's soon realized that this kind of breaks open source licensing. And the reason, it actually does kind of break open source licensing in general, but it particularly breaks the GPL and copyleft licensing. And the reason is pretty simple. The legal foundations are based on distribution. So the normative definitions I talked about are all kind of based on, distribution. The licenses, the familiar licenses in open source, there are conditions in these licenses. There are things you have to do for at least with some of the licenses. They're generally all triggered by distribution. When you have SaaS, you no longer have distribution of code. And so, if you use the GPL in a SaaS context, you sort of escape the intended obligations under the GPL, even though you're doing things that are sort of similar to what distributors do, because the requirements in the GPL to provide source code, if you distribute a binary, the requirements to license derivative works, modified versions under the GPL, that's all distribution triggered. So in a sense, with SaaS, copyleft GPL licensed software becomes equivalent to permissive licensed software. There's also, this affects permissive licensed software too, because these licenses do have some requirements. They're pretty minimal. Well, some of them have some requirements. They're pretty minimal, but they do have requirements that some people usually mistakenly called attribution, but you have to replicate information. When you distribute like an MIT licensing, you're supposed to replicate a copy of the license, the copyright copyright notice, which is usually the author's name. So people think of that as attribution. That also breaks generally in the SaaS model, the SaaS context. So this is kind of a crisis. And so there were responses to this. It was called a loophole because it was perceived as a loophole in open source licensing. And some of the responses, again, there's this element of human agency. So some of the responses are kind of based on principle. People are like sincerely, non-cynically worried about the integrity of open source. And others, again, kind of see an opportunity to exert leverage. Yeah. So just some obvious examples. What I think is a well-intended solution is represented by something like the AGPL, the Affero GPL. So this is sort of an attempt to patch the GPL. I mean, there are actually multiple versions of the AGPL, but thinking of it as one version. To put it pretty simply, it's an attempt to patch the GPL so that there is a trigger that is not just distribution, but basically deployment of a service becomes a sort of trigger point. I would argue that AGPL was well intended, but I would say it is not that well designed to combat the problem it was created to deal with. And I think that's an example of what I was talking about before, that we reach for licenses, when we see these problems, and we try to just like make little fixes, and that's AGPL is kind of making a little fix to an existing license, and it doesn't really solve the problem that well. And in fact, pretty much as soon as the AGPL, the current version of the AGPL is published, it is mostly picked up by businesses using it in a dual licensing context. So other things that happened historically, there were other licenses, they're kind of forgotten today for the most part, but other licenses were promoted by companies to address this loophole, but they were not really motivated by protecting the commons. They saw a business opportunity, right? And this was not generally seen at the time as a bad thing. I think it was only very gradually that people started, when I say there were arguments in open source, sometimes these arguments happen very slowly over time, and the perception that there was something wrong with this was not immediate. So there's lots of things you can kind of point to as sort of like opportunistic responses to this perceived loophole. So another development that's quite different from what I've been talking about, but I think is also in itself an interesting sort of infrastructure shift, and it shows you how kind of expansive this concept of infrastructure is this relationship of open source to brand identity, open source as a brand. So one of the features of open source that is kind of problematic is that it is a brand. There is brand equity in open, but it is kind of a weak brand because there isn't really a good way to protect it. So the open source initiative, in a sense, was set up to try to provide that protection, but they couldn't. They famously were not able to trademark open source itself because open source was sort of assumed to be a generic term, I guess. And so people can use, and people were using open in technology before there was open, people used the term open source. So open is just a weak term. And the thing that I think was kind of surprising in the history of open source was that open source in itself became this valuable brand. And in some ways it became more valuable than the substance it was supposed to represent. And so there was this ambiguity, and again, it was weak, so you couldn't really combat loose uses of the term open. So open becomes this gradually misused term, and it isn't really clear what to do about that, and that's a kind of new control point that created new control points Those new control points were exercised by some people. There were, going way back in the history of open source, going back to at least the mid-2000s, but maybe earlier, people were pushing, I would say earlier actually, people were pushing the concept of open towards more and more restriction, more and more restrictiveness, kind of really stretching those normative foundations or kind of entering into conflict with them. And sort of like taking advantage of this ambiguity about what open is and making open into a kind of monetizable asset. So one of this caused a lot of different types of problems. One of them that is contemporary that you probably are familiar with is the phenomenon of what's called source available licenses. So source available licenses are this set of licenses that mostly have been introduced in the past 10 years, mostly used by like startups that got built up around a popular open source project. And the usual narrative is that after like a few years, they find that people are using the freedoms they gave them through the open source license, typically not a copyleft license, which is interesting. Because they often will pick, by this point in history, a non-copyleft license because it's a faster route to popularity usually. So they pick a non-copyleft license and people exercise the permissions that the company is giving them, and they, in some cases, provide cloud services based around operating these projects, maybe better than the original company can, or maybe there's competitors who create modified versions or fork the software, and so source available licenses are designed to look like they're licenses that are intended for public source code projects, like projects hosted on public GitHub, typically, but they're lacking some of they don't comply with the normative definitions of open source, usually because they don't give you they discriminate against some class of users. So basically, there are different versions of these licenses, and they try to deal with this in different ways. But they're ultimately sort of aimed at competitors, without sort of saying if you compete with us, you can't use this software. They're not honest in that sense. I will mention HashiCorp again here. HashiCorp famously, and maybe this is why apparently there's no one here from HashiCorp. There's like some open tofu people here, right? Like, so HashiCorp a few years ago. So HashiCorp was acquired by IBM like a couple of years ago. Before the acquisition, or certainly before the acquisition was announced publicly, HashiCorp, as an independent company, relicensed its major projects from the Mozilla Public License, which is a weak copyleft open source license, to something called the Business Source License, which is a license that basically says you can use this, but not in production. And then in 4 years, it turns into whatever, I guess the MPL, or maybe it's some other license. That's not the worst kind of source available license. So I do not like source available licenses. When HashiCorp did this, by the way, I did not know about, I don't know when I found out about the IBM acquisition of HashiCorp, but it was, I think when it was, I'm pretty sure it was when it was made public to the general world. But I said on social media I was very disappointed in HashiCorp because I admired HashiCorp so much as a company, and I saw a lot from afar. I saw a lot in HashiCorp that I see in Red Hat, and so that I was very disappointed in that. So I said that publicly. So I sort of stand by that. Source available licenses are designed to kind of, one reason why they're bad is that they exploit this confusion about what open means. So these licenses, or at least some of them, look like they're open source, like to the casual observer. If you're not like an expert in open source licenses, if you're not like really clued into this stuff, you might think of these licenses as open source. So you might assume these projects are open source projects. Sometimes it's because the companies will refer to these projects as open source even when they change the license to one of these more restrictive licenses. Sometimes it's not really the fault of the company directly, but there's no question that part of what gives power to these licenses and the business models enabled by these licenses is the confusion it is exploiting around the existing confusion around what open means and what open source means. So source available licenses just exacerbate some of these problems we've seen historically around asymmetry and so forth. Now, interestingly, around the same time that source available licenses become a big problem, this movement, a splinter movement in open source starts up called the ethical source movement. And it's just, I don't know, it doesn't really fit in so well in the model I'm talking about, but I think it sort of should in a sense. So the ethical source movement believes that open source, they identify as open source, developers, users, but they believe that open source licensing is flawed, and that those normative definitions of open source are flawed because open source allows you to do all sorts of bad things. The concern about like open source being used for nefarious purposes has been around for a long time, and it's true that open source in a sense is morally neutral in that it is based on all these freedoms you're getting, and the freedoms are available to everyone. That's like part of the definition. There's this anti-discrimination principle in the open source definition. You can't discriminate against users, or you can't say the GPL is available as long as you're a good person. Some of you may know the old JSON license, which was the MIT license that added the sentence, the software shall be used for good, not evil. That's like, in a certain sense, I think that was never entirely serious license, but that in a sense is the forerunner of ethical source licenses. So the ethical source movement creates these new licenses, and the licenses say stuff like, you can't use the software for any use case that violates human rights law, or things like that. So there are all sorts of problems with the ethical source licenses. But the reason so the way it fits in with this idea of a recurring pattern, I think that I would actually say that the ethical source movement, in a sense, is its own infrastructure shift. So it's the realization among open source developers themselves that they have to do something to stop the bad things that are happening with the use of open source software. But how do you do something? You can't you're not empowered to write new laws. You're just, you're a software developer. You're not in government necessarily. So the only tools you know how to use are licenses, because those are the existing tools, the foundational tools of the whole system. So they write new licenses, and the licenses then create, leverage points or exercising these new leverage points. So, the licenses you may support the aims of the ethical source movement, but the licenses are designed to kind of allocate power to certain people and deny power to other people. So they create new types of asymmetries. Which brings us to the present day with AI. And the thing about AI is obviously its own infrastructure shift. AI kind of repeats all of this stuff in different ways and in more intensified ways. And the main thing is there's all sorts of asymmetries around what we're calling AI now, and they're more extreme than anything we've really seen before. So there's a lot of things we could say about the relationship between AI and open source. So I'm tempted to just say AI has nothing to do with open source, which isn't quite accurate. AI in the modern sense is built on a foundation of lots of important open source projects. There are ecosystems of open source projects built up, authentic open source projects that are built up around the use of AI models. But within the world of people creating AI models themselves, the term or concept of open is used extensively, but it's used pretty meaninglessly. And then unfortunately, people using the technology then repeat this problem. So the ambiguity around open just gets worse and worse with this, in this AI era. So open source in the AI context basically just means a model is public. It's possible that it's even fair to say that open source is used even more loosely than that. So open is like pure, it's actually worse than what we have with source available. It's just a signal with no substance, behind the signal. There are other aspects of AI that you could focus on. So there are licenses used in the community of people developing models that are are an offshoot of the ethical source licenses. And some of the practitioners creating these licenses have wanted to refer to these as open source licenses. So they are contributing to the problem of, and this term is called open washing, if you haven't heard that, by the way. So this misuse of open in a sort of open source context, it's called open washing. But also, like, models, the big issue is that models, which might be described as open in some cases, and of course, I didn't even mention OpenAI, the name of the company, but I'm talking mostly about like models that are distributed publicly. Models arguably don't meet the normative definitions of open source if you were to think of them as something akin to software, because there is no source code in the sense that the training data that is used to create the models is, as a rule, with maybe very rare exceptions, as a rule not published. Often it can't be published, but even information about the models' training data is not disclosed. So there's this kind of extreme of non-transparency in a context where the term open source is being widely used by the practitioners creating the models and even the people using the models, which is quite unfortunate. So you might say, like, can't we solve all this by creating a new license? And I think by now you know my answer to this is that licenses are they're not good at solving these problems. You can try to solve some of them with a license, and some people are trying to do this. So some people who are very angry about AI, so they're in open source, have proposed like creating new licenses that basically say you can't use this software to train a model. Now that violates the open source definition pretty clearly, but people proposing these kinds of models think of them in some sense as being legitimate open source licenses. But it's not even clear that like licenses could effectively solve these problems are so big that licenses are just like very, very brittle tools. They can't do that much. They were very effective for the limited purpose they had in like the 1980s and 1990s. The problems we have today with all of this changing infrastructure, as I've called it, is so complex involving so many different types of issues and problems that you can't have a single type of tool address it. You need multiple types of tools. A license is just it's the wrong type of tool for most of these problems. Maybe for some of them it can affect some of them. So we've seen this before, but it's really, is my mic off?
Take two.
Okay, hi. Can people hear me now? Yeah. So licenses are not the solution. So I think James, when James was talking to me about like doing this talk, he said I should try to be inspirational, and I'm not used to doing that. So I mostly just like complain about stuff, as you probably noticed. I've mostly complained about everything that's going wrong in sort of a confused way, and so trying to be somewhat inspirational. I think that the problem, I think I've identified a problem that is a real problem, that we have, the way we conceptualize open source is rooted in the past and doesn't get updated for these new problems. And it's just getting worse and worse. And you can't, and it's not just a matter of like having new versions of the same old type of thing. The concept of tools being mostly licenses and the definitions that licenses are built on isn't good enough to solve the increasingly complex problems around open source that we experience. So my thought is that the problem is that this traditional notion of freedom that open source is built on is a static concept. And what if we instead try to reframe these freedoms in a way that is more dynamic or adaptive or as I'm saying here, mobile. And so here's like an attempt, a very crude attempt to map those original 4 freedoms to a kind of reframed mobile, what I'm going to call mobile freedom. So instead of run, study, modify, share, reproduce or rebuild, verify, participate, exit, and then there's like a new concept, sort of a counterweight that is stewardship, referred to as stewardship. And these would, in a sense, address places where the original freedoms have become sort of hollow because of the kinds of problems that have occurred. So just going through these kind of quickly, the right to reproduce. I mean, this is not an original idea in any sense. It's kind of a generalization of the work done on reproducible builds. So we actually don't, even though in a certain sense the GPL is designed to enable users to rebuild software from source code, it doesn't do a super great job at that. I mean, it's the best mechanism we kind of have right now from a licensing standpoint, but it's not enough. Like, and for systems that are more complex than just like, source code. Source code is, being able to rebuild source code is not enough. So I think, in a sort of foundational sense, there's a need for a more robust notion of the right to rebuild or reproduce. Verification, this is a little bit, I think this makes sense, but I think it's a little bit more hazy. I think that increasingly things that are adjacent to open source or that are claimed to be related to open source involve, so they involve claims that can't be verified by users. Like an example might be someone claims to be running a service based on an open source project, but maybe they've actually modified it in some substantial way without publishing their modifications. How can you verify the claims they make about those things? You can also think of this as applying to the governance of open source projects. So projects might claim to be vendor neutral, for example, or to use certain voting techniques for making important decisions in the project. Well, how do you verify those claims made about governance? So verification becomes a type of mobile freedom that we can conceptualize now. And then I mapped the right to modify, obviously a fundamental part of the original definition of open source, with this idea of participation. So of course you need the right to modify, but you also, you need if you are dependent on a project, there's a sense in which you should have some way of participating, ideally, in the governance of the project that you share in and that you depend on. And that is modification is a local freedom. Participation is more of a collective freedom, a sort of notion of collective freedom. And I'll mention stewardship in a moment. So this is not, this is not some sort of radical proposal for open source development to become like a free-for-all with no sort of standards of contribution, but it's sort of elevating project participation to the level of the original freedoms. And then, something I've thought about for a long time. So everybody, talks about how the right to fork is fundamental to open source, but but it turns out in practice, and this has become increasingly true over time, is you can't easily fork projects in most cases. Like you're dependent on a project, let's say it changes license to one of these source available licenses. If you don't have the expertise or enough resources, the freedom to fork is too costly to actually practically exercise. So, you know, another aspect of this is that I think open source should more explicitly state that it is built on the, you know, this idea of the right to compete, which is, you know, directly kind of in conflict with these source available licenses. And then this idea of stewardship. So stewardship is sort of the counterweight to these sort of reconceptualized freedoms to, you know, reproduce, verify, participate, exit. Stewardship corresponds to, you know, the work you need to do to sustain projects and communities. So obviously something that people have been concerned about for a long time. Again, it's something that ought to be elevated to the foundational level for what open source means. I think you know, these flashpoints that occur in the history of open source, especially around legal stuff that I've been kind of talking about, they're not evidence that there's something wrong with open source, really. I actually think it's actually a sign of a strength in open source. Again, I'm trying to be sort of positive about this. I think open source is a self-correcting system. It often seems to take a long time to correct the problems, to come up with solutions. But I think you know, I would embrace this idea of open source as this constantly correctable you know, system. And that's again why this notion of mobile freedoms is, I think, something that we need in some sense. So I want to kind of say that it's important to recognize that this is a human endeavor. So these so-called freedoms that I have tried to articulate, reproduce, verify, participate, exit, stewardship, they actually correspond to real human activities, and that is very important to think about when thinking about what open source ought to mean. So the right to reproduce is based on, you know, curiosity. The right to verify is based on integrity. The right to participate is related to the notion of solidarity. The right to exit corresponds to the concept of courage. And stewardship, of course, corresponds to care. So these are all human forms of these kinds of reframed definitional freedoms. And also I want to make clear that I'm not proposing that we replace the existing freedoms or the notion of what an open source license is. Those are still going to be a foundational part of open source for me. But I do think that we need to have a bigger sense and more expansive sense of what open source means definitionally, that is not just rooted in these kind of static checklist of permissions, 1990s, 1980s kinds of concepts. So I think the thing is that I would conclude with is that, you know, asymmetry is something that's inevitable in open source. It's just a feature of this phenomenon of infrastructure shifts. There's always going to be changes in the field of play, and that's going to create different power relationships and leverage points. What we can do is make sure that power doesn't get ossified, and that's what this notion of mobile freedoms is sort of aimed at. It's aimed at making sure that when concentrations of power come up in communities and around software and systems, we have some way of understanding how to think about that and how to possibly think of changes to them that can try to alleviate those power concentrations and in a sense keep openness and freedom moving so power doesn't end up getting stuck at any particular point. So we can keep asymmetry negotiable. We can't eliminate it. And I think that's a somewhat hopeful view. And that, I think, that is all I intended to talk about. Have I exceeded the...
You're okay. Let's have a round of applause for Richard.
Thank you.
Thank you. So just a quick, so we're going to take a break in a moment. We're going to first give Richard some time for questions.
Yeah.
And if you have some questions, give them a shout. Raise your hand. Yeah, all the way in the back. Just please repeat the questions too.
That sounds like some, I basically heard half of that, so I didn't hear the whole thing. If,
I'm gonna run up.
yeah, maybe. It sounds like, it sounds like an interesting question.
Over here. Someone else had their hand up and we'll come up with a mic for you. Yeah, gentleman in the red.
Yeah, so there's a process going on to get a new license for AI, for LLMs. I don't know exactly who did it, but it's a large project worldwide. Maybe you can comment on that process?
So you could be talking about any one of a number of things. Are you possibly talking about the open source AI definition?
I guess so.
Yeah. So I didn't mention the OSAID. So although my criticisms of the OSAID have been all over the place, I've been a critic of it. So the open source initiative a couple of years ago decided to embark upon this pretty ambitious project to create a new definition, a new open source definition specifically for AI. And that, yes, that would become sort of a basis in part for judging licenses, but it was also is sort of more ambitious than that. It was sort of aimed at it was well motivated. It was aimed at trying to combat this problem of open washing that I referred to that exists in AI. The problem with it is, what I would say is the main problem with it is that it was, they came up with something too complicated and too impractical, and also it didn't make anyone happy anyway because it has this big compromise built into it. So it basically tries to address this problem of non-disclosed training data, but it does so in a way that has a kind of hole in it, and there's a justification for that. But that made no one happy, and anyone who has a sort of position on this sort of debate that's going on. So it just, I think it was sort of pointless, frankly, and it seems to be something that the OSI has not paid much attention to recently. So I think it is not a successful thing, and I think maybe, does it fit in with what I'm talking about? I think it maybe shows that trying to come up with a definition similar to the open source definition is not the right approach to address this problem, but I'd have to think about that some more.
So just we're going to do some more questions if you want to stay around. If you do want to go on the break, we're going to be back here at 11:30 sharp for Adam's talk, which will be questions in the back here.
What's that? Oh, yeah. You want me to get them to pay attention or something? Is that what we're doing?
I gotta do that for you. I'm your hype man.
Right?
Hi everyone, stand down. If there's people
Yeah, yeah.
next to you, please move in. There's a space. Joe, I saw that. I know what's going on. Okay, keep it up. Everyone here in this row, there's room in the middle, please move in. The third row, the sixth row, the 13th row. If you see a space towards the middle, please move in. Thank you. I've paid a whole bunch of stand-ins to make Adam's talk look more popular, and we really need to fill the seats. So otherwise they don't get paid and I don't get paid, so yeah, please, move in. Oh, one's for you?
Yeah, which one?
Whichever you like.
This one.
Check, check.
Yeah?
So,
Ooh, one whole minute left.
What?
One more minute.
Well, yeah. I have the pleasure of introducing Mr. Adam Jacob. You might have known him as the founder of Chef back in the day. Who's used Chef before? Who still uses Chef? Okay.
That's fine. I still love you. I haven't used Chef in a long time.
So Adam's a great conference speaker, and we gave him this talk on the condition that he would give us lots of live demos. So hopefully we're going to get to see something cool today.
James is full of shit. There will be demos, but I don't know about lots.
He's the founder of a company called System Initiative, and he's going to tell you a story. So please give him a big round of applause.
Good job making it back from the break. Yeah, hi. Let's get straight into it. Yeah, we'll just go. Let's do it. I'm Adam. We're going to talk about AI native automation, and I'm just going to give you the TLDR of the whole talk up front. So instead of making you wait for the reveal, this is everything I'm going to say, and then I'm going to come back to it again at the end, and then we're going to work it all out. So look, here's the deal, and some of you in this crowd, I think, are not going to like the deal very much. But I need to just tell you that I'm telling you this out of real love. This is the room that I feel most comfortable in. You are the people that I most identify with. Like, I love the things that you love. Like, and that's why I'm here saying these things to you. Like, because I think that they're true. So AI is the future of software development. It just is. Every objection you have, and I'm sure you have some, I'm sure you have many, they will all be overcome. It doesn't matter what your objections are. The reason is that the velocity increase is too high. It's simply it has too much utility, right? It's too useful to imagine that anything's going to happen, except that utility gets consumed. It will get used, that's it. And operational velocity follows development velocity. So anytime that there's an increase in developer productivity or developer velocity, there's an increase in operational velocity, right? And that means that we will have to get better because we are going to have to match the pace of what's happening in software development, which is getting crazy. The existing tools, let's be frank, barely enable the velocity we need now. Yeah? Raise your hand if deployment and operations is the bottleneck of getting software into the world at your company. Yeah, and there's some people that are waffling, but they know the truth, right? Like they don't want it to be true, but they know. So you have two choices. You really do. You either figure it out together. This room figures it out because we are the people who, at this point, I think, are probably the largest gathering of people dedicated to operations and automation anywhere on the planet. I don't think there's a bigger conference that actually solves for this problem. And I wish there was, because I'd go. But there isn't. We're it. We are the final bastion of people who get together and talk about these problems. And so either we figure out together how to fix this and how to move forward as a team, or we will wait for someone else to do it for us. And honestly, that's incredibly boring. Yeah? So I think what we should do is figure it out together. And so what I'm hoping you'll take away from this talk is that you should flip. to the team that says, yep, this is going to happen, and what we need to do is figure it out, and we need to do that together, and it's going to be super fucking fun. Yeah? Okay, that's the talk. You can go. If you're like, fuck this talk, now's the time. James is out. See you later. Thank you. Okay. We'll back up. I'm Adam. He introduced me. Many of you know who I am because I've been coming here this whole time and will come until they decide I can't. I think of myself mostly as a systems administrator, even though I haven't been one for a while. I was the CTO at Chef. I wrote Chef originally. I was there most of its time. Now I'm the CEO of System Initiative. I love open source in a way that is like deep and fundamental and sometimes annoying to my partners and to those around me, because I really believe in the power and impact that it has had on my life and on yours and on the life of others. And so I'm an absolute open source kind of free software true believer. And I kind of love you nerds a lot. Like you're kind of my people. And I started this company, and it's called System Initiative. I started it 6 years ago, which feels like an eternity in startup time, because it kind of is. And the goal of System Initiative was to figure out how to build a better infrastructure automation solution. And we did a bunch of really ambitious things. We tried a bunch of different angles and approaches. I think we probably built 6-ish, maybe 7 different, completely different product ideas over the course of those 6 years. Just trying to figure out like what would be better. Because I think I had been looking at this problem of like, you know, we do all this work and then we have to go operate it. And then when you talk to people who actually do the work, they're like, yes, it's working, but it's misery, you know? And I was like, we got to figure out how we can make this thing sort of be less miserable. And I'm proud of the ambitious things that we tried. I'm proud of the work that we did. I'm proud of the team. But ultimately, we failed to build something that was good enough. As evidenced by the fact that raise your hand if you loved System Initiative, like used it and loved it. The only people who are doing it are people who work for me. And so, look, I failed those people who worked for me. I failed all of them. I had to, last week, I had to let a lot of them go, and I love them. So many of them had worked for us for 6 years or more, and it was the right thing to do because the product just simply failed to find any fit. You didn't love it. And I kind of failed you because when I started it, I was like, I want to serve these people. Like, I want to figure out how to build something that makes these people's lives better. And I just resoundingly did not. And so last week, we faced up to that, you know? Like, we had to do the right thing and go through that. And then this week, a small team of people decided to try again. And so that's what we did. This week, we're going to do it again. So a question you should be asking is, why try again? Because there's easier things to do in your life. I build startups for a living. I'm good at it. I can raise money. I like raising money. I like building teams. I like all of those pieces. I could just go do anything at this point that I want to do. But the truth is, there's a couple of reasons, really 3. One, the last 6 months in AI happened. And so if you're not a person who's been really paying attention to this, you might not notice that something changed, or it might have just always felt like the same cycle of hype, you know? And so you've just tuned it out because you're like, it doesn't really matter. Here's the truth. Across the industry, kind of all at once, in the last 6 months, we all figured out how to use AI to be incredibly effective at writing software. I mean, crazy person talk. And it happened in small pockets, inside large organizations, inside small ones, and those people started talking to each other. And some of them were talking into the internet. They were like, this is incredible, and we are going to take over the world. And you mostly ignored those people, right? Because you've been sick of their prattle, right? For the last year and a half, right? Which, peace. You know? I get it. And it happened. And they started talking to each other about what they're doing. Turns out they were kind of doing the same things. And at System Initiative, what changed for those people, sorry, before I get into System Initiative, what changed for them was that they figured out how to use this as technology. Not as hype, not as dreams, not as, Terminator robots, but as actual things, just like you use Postgres or write a shell script. And they figured out how to use those things to actually solve their problems. Yeah? And that wasn't true before. That's why you were skeptics, right? It's okay to be a skeptic. You should have been. I was too. I'm going to get to this again later. But, that happened. Now, At System Initiative, we saw a glimpse of that future. I would say maybe 100 days ago, 180 days ago, we took some prototypes that one of our customers built of using MCP to talk to System Initiative that sort of like showed a glimmer of being awesome. And we were like, you know what would be awesome is if somebody who actually knew what they were doing maybe built one of these. And so we did. And it turned out it was ridiculous. It did crazy things. We did things like, we had people show up cold, have production issues, say, hey, we're having this production outage. Here's the description. Go discover any infrastructure you need in AWS and troubleshoot this bug. It found 2,000 pieces of infrastructure, modeled those things, analyzed them, and found the bug in concert with the source code in one shot. That's insane. That's crazy, right? We saw it do things like translate architecture between AWS and Azure. We said, we have an app running in AWS. Here's the source code. Now translate that to run in Azure, and it did. And it did. Again, crazy talk. How long would it take you to do it, right? Just ask yourself, how long will it take you to look at your app running in AWS and move it to Azure? I'm not saying it's like an impossible task or whatever, but this happened in like 20 minutes, right? Less, right? Crazy. And one of the things that happened for me is I never want to build infrastructure in any other way ever again. For the rest of my life, I'm going to build infrastructure most likely by working with an agent to do it. Because I don't remember most of those things. I don't remember how to put together all the things that I need to put together to run something well in AWS. But the agent does, and that loop was just better. And we saw that loop, and once you see it, you can't unsee it. And then finally, I'm just not done, and neither are the people that I work with. Like, we love this problem, right? We love this space. We love you. We love this work. And so we just weren't done doing it. So what changed with AI in the last 6 months? Why was there this moment that we crossed that can never come back from? One, the models got better. So the frontier models have been improving. They've been improving quickly. But how many of you used like AI to write some code and it was shit? Yeah, the whole room. Exactly, me too. And so, but it turned out that as those models improved, not all of them, but most of them, in the last 6 months, all got good enough. They crossed some threshold where suddenly, with the right set of prompting and the right set of behavior, the code they're producing is actually pretty high quality. And it actually seems to work. The second thing that happened was Claude Code. And why this is important isn't actually because Claude Code is so much better than any other possible thing that could write code. It's actually because it's not an editor. Because historically, what we've been thinking is, I'm going to use this AI to augment my ability as a software developer to write code. But I'm responsible for the code. I'm going to be reading it and understanding it. I'm the one who curates all these lovingly built functions and words and stuff on the screen, right? And Claude makes that very hard to do. If you've ever used Claude Code, it's just a terminal window and it's like, I'm writing code, you know? And at first you're like, oh, I better go read all the pieces and it's kind of slow. But once it works for a while, you stop doing it. You just do. You're just like, yeah, man, let it rip. You know, let's do it, let's go. And it happens to everyone who tries it. It's the same thing that happens when you sit in a Waymo. How many people got in a Waymo in San Francisco? Maybe not very many because you're in Europe. It's bananas. The car drives itself. When you first get in the car, you're like, this can't be safe. And then the car pulls out and it takes 10 seconds, my friends, 10 seconds for you to be like, this is normal. It's fine. And you just trust that car, it's cool. Because it's just a fucking car, yeah? And it's fine. And that's what happens when you use Claude Code. And then finally, it is just technology. We figured it out. It's not crazy. LLMs are just LLMs. And they do what the thing that they do. It's not magic, it's just boring. It's just technology. It's fine. It's Postgres. It's Bash. It's Perl. It's Ruby. It's whatever you like. It's fine. It's fine. It's fine. It's just technology. Relax. And we all relaxed. The whole industry filled with technologists, not everyone, obviously, because some of you still hate this talk. But most of us who were like talking to each other in the background, were like, yeah, I get it now. It's fine, right? It's fine. Here's an example of what really changed the most, and the answer is velocity. It took 6 years for us to build roughly 6 or 7 versions of System Initiative, right? In the last 180 days, we built a version that actually almost worked, but was stuck with all this weird baggage from all the previous iterations of System Initiative that you hated. right? You were like, no, I don't want to give up source control, you know? No, I actually don't care about visualization, you know? Like, it was still had all this baggage from those decisions. But in the last 3 days, we built the bare bones of a new product that does the vast majority of what System Initiative did, essentially single-threaded together. And it has terminal UI, it has its own agent that works on it, it has a web UI. We did in days what would have easily taken us months to do by hand. Easily. And I know because I've been building it over and over and over again by hand. It's wild. And the quality is quite high. So who cares if I spent the last 6 years getting the product wrong? Now I can get a new product, get it wrong in days. I have so many more shots on goal. I have multiple people in my life who I love and respect, who I know as actual people with their faces, who have had conversations that are something along this line, which is, I am sitting alone and I am generating 50,000 lines of working code a day. 50,000 lines. Now, a reasonable reaction to that is, why? But the truth is, it doesn't matter, because if it works and solves the problem, it's phenomenal. And that is the truth. That every single person in this room right now has all the skills required to generate 50,000 lines of code a day. That is wild. That means that there's literally nothing in the world that you have ever seen technologically that you couldn't reproduce if you just had the money to burn on tokens. That is fucked up. But it happened. It's true. The impact of this on velocity with software developers is roughly the impact between the size of that text and that text. So if you think about the impact of DevOps and cloud on our collective velocity and the seismic impact it had on operations. How many of you are old enough to have done operations work before the cloud? Oh, I love this room. It was a big frickin' deal, right? Like we did good work, right? We changed literally the planet. Every organization around the world became a software company because we figured out the operational side of that work. That was incredible. And it is nothing compared to the acceleration that just happened. It is nothing. I am underselling it. Do you get it? I'm underselling it. It's crazy. Look, when software development accelerates, operations always follows. It must. The code has to go somewhere in physical reality. It has to do something on computers. It still needs those things. It still needs networks. It still needs all that stuff to happen. That's what we do. But the way we have done it historically, we're the bottleneck now, right? What stops your company from going faster? It wasn't that it couldn't hire software developers. We've been cranking software developers out because it's an incredibly well, high-paid job for a long time, right? The reason that companies stop buying software developers is because they can't deploy it fast enough, because the operational burden is too high, because the loop of troubleshooting is too big, because they can't react to failures and errors fast enough, because they can't do security review. They're going to solve all those problems. And what are we going to do? We're going to fucking use Terraform. That's our big plan, right? Come on, we have to change, and we have to change radically, because it's obvious. We're the bottleneck now. It doesn't work fast enough now. There's no way it survives that kind of change. So the time for you to be a skeptic has passed. It's okay if you walked in this room a skeptic. I was a skeptic. My wife is a delight, and she has a lot of people that she works with who do like social justice work, and they got very hyped about AI immediately. And they went off on wild tangents telling me about all the crazy things they were going to do. And I was like, no, you're not, you know? And they stopped talking to me about it because I was such a skeptical dick, you know? They would literally stop talking to me. They were like, we're not hanging out with Adam anymore because we don't want to hear him poo-poo our dreams, you know? Because the hype was insufferable. It was awful. And real harm is happening to real people that we know and respect, right? It's awful that those things are happening. It is. But it already happened. And nothing is going to stop that change now. Somebody asked a question earlier about like, what happens when the bubble bursts? Won't that just wipe it all away? No, it won't, because that velocity increase has already happened. You think the bubble bursts and what happens is we take the most productive people and they lose their jobs? Be real. Be real. It's not. It's not. What happens is we lose ours because we didn't figure it out and they did. The utility's too high. It's not going to collapse. Like, I'm not saying that bad things won't happen. I'm not saying it's not seismic. It is seismic. I'm underselling it. That's how seismic it is. But we have to figure it out. We either adapt or we get left behind. Those of you who know me well enough know that I like heavy metal. This is Randy Bly. He is the lead singer of a band called Lamb of God, What's Up? And Randy's been in this band, very heavy band. They make, really awesome heavy metal music. You should go listen to Lamb of God. But they've been writing songs together for 30 years. And I don't know if you've ever had friends who you do something with for 30 years, but you kind of start to hate each other. Like you spend 30 years picking on each other, and like farting in a bus or whatever, and you just don't want to hang out with people anymore. And so when they write songs, they have a problem, which is that if you write the song first, and then somebody comes and changes the song, what you want to be is like, no, that's not how my song goes, right? You want to be like, I'm over here playing, I'm killing it. And then somebody else comes in, and they change the note, and you're like, ugh, I don't want that. And you have to resist that need because they have a saying, and the saying is, good is good. Sometimes things happen that are just good. They're just better than the thing you wanted to have happen. What I wanted to have happen was everything stayed the same. I love being a software developer. I love writing all that code by hand. I love all of it. Doesn't matter. Doesn't matter because good is good. Turns out it doesn't matter the song changed and you don't like it. It's still changed, right? And all we have to do is adapt. We have to get better. Okay, doesn't matter how you feel about it. Good is good. Let's talk about how this is working in software development. So roughly, you wind up with a process, if you're going to accelerate to this level, that works something like this. You have this idea of software architecture. How many people think of themselves as a software architect? A few of you, which is great. How many of you have made fun of software architects? Yeah, way more of you, right? Me too. Turns out, the thing that they're great at is the thing you have to become great at in order to use LLMs to write software at this velocity. Because you know what they're good at? Really specific vocabulary that has really specific examples of its behavior. Have you ever been in a code base that was written by hand using design principles like domain-driven design? You ever had to write code that was always supple to requirements and decoupled across all of its things? How many people have had to do that? Did you like it? Put your hand down. No one did. It's insufferable. It's insufferable. Even though you know it's good for you, it's like wading through a sea of nothing but broccoli. But you know what's good at doing that? LLMs. They don't care that it's insufferably hard to write great architecture and clean code. They'll do it all day, because they can write 50,000 lines of code a day. The only problem is you don't know how to do it because you decided it was boring and stupid and slow. Yeah? But now it turns out it's exactly what you need. It's exactly the thing you need. So you have to have an idea of what the architecture is and a vocabulary to express it. If you don't have one, if you're thinking, what will mine be? A good answer would be domain-driven design, because that is a very good, and it thinks about vocabulary in a very specific way. But it doesn't matter what you choose. You also have standards. You have ways that you work in order to write software for your domain. So you take those things, go into a process that probably looks roughly like this. You design things, you plan them, then you implement them, then you test them, then you review them. This is probably your process today, yeah? Raise your hand if it looks something like this. You're like, yeah, we don't do as much planning. Don't do a lot of design. But like, it's roughly right, The things in green are what's left for you. Your job is design and planning. That's it. That's it. You don't implement, you don't test, and you don't review. Because the speed at which those things happen has exceeded your tiny brain's ability to grasp what the hell is going on. You can't do it. You can't do it. You simply can't keep up. But you can keep up with design. You can keep up with, yes, I think that is a smart change to the software architecture. Yes, I think that is a reasonable way to think about implementing this problem. Magic machine. And then it's going to go and do all of those things, right? You have questions. I have no doubt. you're going to start with, are you reading the code? The answer is, not really. Not really. I can't. It's going too fast. With 30,000 lines of code a day, 50,000 lines of code a day. You're not reading that shit. No way. No way. What you are reading is architecture. You're reading documentation. You're writing standards. You're reading the code for guidance, and you're spot checking to make sure the architecture doesn't go astray. I'll use an example of this prototype we were building. John Watson, who's a delight, he's right here. He built an implementation of secret storage that he cleverly called vaults. And the way that, that he implemented vaults, John's never done domain-driven design. And so he told it how to build vaults, but then it went and wrote code according to what John told it to do, which violated the architecture principles of the software. And I could see it in the outputs, because I am a pretty good software architect. And I was like, there's no way that PR is designed correctly. And I only saw it after the code landed. He had a working version of vaults, but I looked at it and was like, no, that can't be right. That smells bad. Turns out it was. And then we fixed it, and it's fine, we just moved on, right? That's incredible. I didn't actually review the code to do that. I just looked at the outputs and was like, there's no way that's the right shape, and then we fixed it to be the right shape, and then I spot checked it, right? You're really just looking to catch derailment, which happens way less often than you think it does if you follow a reasonable pattern of working with these tools. 2, human review just simply doesn't work, right? The velocity is too high. I've harped on it, but could you review 10 2,000-line pull requests a day? Because Paul Stack sent 5 of them yesterday. 5. So you can't. What's going to happen is you're going to take all that intelligence you build into the software about how it's designed, about what its software architecture is supposed to be, about the standards that you have, and you're going to let those bots rip. You're going to just make it so every PR that they send, they read again and go, does this match our design standards? And it's going to do such a good job. I mean, a face-meltingly thorough job. You don't do that shit, I know, because I've seen your source code, right? You whiff at architecture. These things, they hold to that shit way better than you do, right? It does a way better job than you do. So you're just going to trust it. You're going to be like, you know what? I worked with this thing. We made a good plan. Seems to work. I validated it. Test pass. Let the robot review it. If it doesn't, then we fix it. Otherwise, merge it. Just move on with your day. Security. That's what you're thinking. You're like, that's the last place. It's like we've climbed a, I'm telling you to jump off a cliff, and you're like, but I won't, because security and supply chain safety, right? That's what you're thinking. You're like, I'll never let that slop into my life, right? Okay, sure, man, fine. 2 things. 1, probably, and this was a thing we realized yesterday, so I reserve the right to be wrong. The answer is you don't accept pull requests anymore. You don't, because you know what you don't need? Anyone's source code. You can generate source code at 50,000 lines a day. You know what I need you to do? I need you to write a design document in my issues. I need you to say, this is how this thing should work, Adam. And then I'm going to read it, and we're going to talk about it. And then I, because I trust my agent, I'm going to let that thing rip. I don't need your pull request. I need your brain. I need your ideas. I need your collaboration. The same thing happens in security. You know where the secure parts of the software are. Not all your software needs to be highly secured, right? No, it's the boundaries. Like it's AAA, it's encryption, right? So yeah, that vault implementation we read, because I think it should encrypt your secrets and not leak them. Yeah, because I'm not a dum-dum. I didn't just tell the LLM, you know, because that's insane. But once you stop doing that, it happily does the right thing. This is a smaller surface area than you think it is for most of your programs. Okay, now you're like, slop, that'll save me, Adam. I don't have to do this because slop, that's going to kill us all. No, it won't. Back to strong architecture and thorough planning. I do have a spelling error I didn't fix, though. Paul caught it yesterday. I should have used an LLM to review my work. But I hate the way they sound. Okay, look, you're going to give it strong architecture guidance. It's going to follow your planning, right? It's going to catch the obvious flaws in the design phase. You'll be shocked at how many bugs you catch just by reading its plans. Just by asking it to make a plan and then reviewing the plan and being like, that's a dumb plan. And then it fixes the plan and then it does the thing you're supposed to do. It's not hard, right? Now, most of you, when you wrote this stuff, the idea of a plan mode didn't exist. Most of you who've fired up Claude Code, you never bothered to hit Shift-Tab and turn that into plan mode, did you? Didn't even know it existed, because it didn't until like 4 months ago, right? But now it does, and you should be using it because it catches these sorts of problems. Okay, let's talk about quality, because this is actually probably the last place we are clinging to the cliff, right? You're like, it couldn't possibly work good enough like my artisanally crafted, we worked hard at this. We got good, Okay, 2 kinds of quality. And I don't know if I'm the person who invented this frame. It doesn't really matter. But one is external quality. Think about it as, does it work? Is it secure? Do people like it, right? This is how it's perceived by your users. This has always been the actual measure of whether or not your software was good or bad. You didn't like System Initiative because it had poor external quality. It did, even though it was kind of rad and like had many things in it that were really cool. The ultimate arbiter of its success was you. And you said, no. Yeah? So no matter how clever it was on the inside, and it was so clever, it was so good, you didn't care. And that means it didn't matter. It was wasted time, right? It's the only thing that ever mattered, and it's unchanged in an era of AI. It's unchanged. If you ship things that suck, they still fucking suck. That's it. And that's why you kind of hate AI right now, because people are shipping a lot of stuff that sucks. And you're like, oh, I don't like this thing that sucks. And you're like, yeah, right. Stop sucking. Yeah? Do better. Your taste, your expertise, still required. Okay, but what we obsess about is not usually external quality. We obsess about internal quality. These are the things that teams need in order to produce high-quality things externally, right? If we don't do these things as teams of people, we decohere in our ability to build things that are good, right? And so some people talk about this as the craft of software development, right? It turns out some of this still matters, but mostly it's just software architecture patterns, because it turns out these are the key ingredient to making AI-generated systems stay coherent in the face of requirements. And if you've ever experienced people who just built really complex things with AI and then they started to fall apart, this is why. Because there was no software architecture. Because AI just does what you tell it to do. And so if you just told it to rip some slop, it rips some slop. Yeah? But if you tell it to write clean, well-architected code and you have a thesis about how that works and you use that vocabulary, it does what you say. Now, what we spend a lot of our time doing is not software architecture, as evidenced by most of you not raising your hand, except to say you made fun of software architects. Yeah? Instead, you think a lot about principles, right? How many people here know what dry is? How many of you believe it's important? Most of you, if you're being honest. Well, it doesn't matter now. Cheers. It doesn't matter because you never read it. What do you fucking care if it wrote 5 versions of opening a file? You don't care. You don't care. It doesn't matter. It did matter. It used to, but it doesn't anymore. Kiss probably doesn't matter because what's simple anyway between friends, Let's talk about Yagni. You ain't gonna need it. This is a principle that I think might survive because at the rate you can write 50,000 lines of code, it's very tempting to just rip through everything you think could ever possibly be good. And that, we know, is bad, right? Now, most of what you argue about on your teams, though, is taste. This is actually the reason you hate AI, because it has bad taste. You have an opinion about what good is like. I love heavy metal. You hate heavy metal. That's taste, yeah? It's okay. But things like how the code is organized, or the style, or naming conventions, they don't matter. They don't matter. They never mattered. But now they really don't, because you're never reading the code. So you gotta relax. Every time you're arguing about taste, every time you're arguing about some arbitrary principle that's how you collaborated with other people as a person, all of it's dead. Doesn't matter anymore. Except as they apply to creating external quality and defining the architecture to ensure the agents don't go nuts. Talking to agents about architecture leads to stable systems, the same way that architecture led to stable systems in the large with human beings. You might have hated software architects, but you love software that has good software architecture. You love it. You just don't like writing it because it sucks. Now, what we've been doing is vibes, right? We've just been popping up an agent. Michael, I think, had a prompt. was a terrible prompt, right? He was just like, I want to do some things, do it. And then he was like, I suffered for 10 hours. And it's like, yeah, surprise, right? Of course you did. You gave it nothing to work with. That it worked at all is a miracle, given how terrible that prompt was, right? But of course it has brought chaos, right? Of course what it brings you is chaos. This is why non-engineers struggle, and why all of us should not anymore. But if you can't express architecture, that's the number one thing you need to learn to do. If you don't know how to talk in terms of software architecture and design, now is your moment to go buy Eric Evans's book, which is kind of impenetrable. It's a tough read, Domain-Driven Design. You could pick up Implementing Domain-Driven Design. That one's easier to read. But look, you pick, I don't care. Pick a different architecture. Ask Keith. Keith probably knows a million things. Wave your hand, Keith. This is Keith. Keith will help you. Okay, look. I just invited everyone, talk to Keith at the Zone about software architecture. Look, what's happening here is a Cambrian explosion of software. It is crazy how fast the software is going to change. There is literally nothing that you couldn't build if you had access to the capital to create enough tokens to drive it. I mean anything. Every single thing you thought was a moat, where the only moat that's left is that people use it. The agents use it. That's all that's left. It doesn't matter. There's no technical moat, none. You're gonna be like, well, it couldn't rebuild Nix. And I'm like, motherfucker, it built a better Nix in a week. In a week. If you knew what to do, if you knew how to say it, if you knew how it should work, it would wipe away all of your sins. That's crazy. It's crazy. It's wild, and it's getting wilder. Okay, what's it mean for automation? I'm going too slow. Look, first it means you have to build for agents first. The primary consumer of automation now is agents, right? People need transparency into the agent and into the outcomes. If you can't see what the agent is doing and you can't correct those steps, the agent can't see them either, right? This is why it needs to be open source. AI native automation, speed is the most important piece of it. There's 5 things it needs. 1, transparency. You gotta be able to introspect every point of the process. 2, it has to be extensible because the agent will unblock whatever it needs with code. The way we built automation in the past was like somebody else built the Terraform provider for AWS, right? In the future, you can just say, build me some automation that does shmoo. And then it will, if the framework is good and the validation is strong, right? You just have to be able to do it right in line. You're no longer blocked because you can generate 50,000 lines of code a day. Has to be one-to-one to the domain. The LLMs are trained on real-world data in the world. So every time you are tempted to build an abstraction to make it easier for your tiny little human brain, what you're doing is making it harder for the agent to do the right thing, right? One-to-one models. Use the training data. Validation. Each step has to have policy embedded because what we do is operations. We impact the real world. When we make changes, we don't just call a pure function with no side effects. Everything we do is nothing but side effects, and they usually cost money and cause problems for people in the real world. Yeah? So we need ubiquitous validation at every stage of this process. We need to be able to say, here's what correct looks like contextually for me, and apply that to that automation process in line, and we gotta be able to write them immediately. This is true at every stage of the process. So if you think about the way you do validation now, you do it wrong. You care about the full life cycle. You have to have visibility across everything. Right now you have automation split across CI and CD through the code base, right? Through all kinds of stuff. Here you gotta have all of that stuff. It has to cover all of it. Troubleshooting, debugging. It needs access to all of that data. This is why infrastructure as code is in trouble, right? It does none of those things well, right? It's not transparent, it's not extensible, it's too abstract, it has terrible validation, only covers part of the life cycle, and it's too damn slow. One way you know this is true is here are the things you talk about when you talk about infrastructure as code. You talk about principles and taste. You're like, how am I gonna factor my Terraform modules? Is it a Teralith or not? Oh, you didn't dry up that, you should have used a loop. So not a loop, I'm sorry, it's declarative. We're not allowed to do loops. Loops are too hard, right? Anyway, obviously wrong, right? So what might this look like? What might this future look like? So 3 days ago, we started taking these ideas and saying, let's take what we learned from System Initiative and what we loved, and let's go build a new thing that tries to embrace these things. And I have a rule that you have to have code names for things that are like this. So the code name is Swamp, but its name is not going to be Swamp, okay? And it's not quite ready for us to like open a repo, you know, and be like, let's go. But it has all these principles in it already, so I just want to sort of go into it. So one is here. Let's see if I can do this. Maybe we'll skip to Keeb, because we only have a couple minutes left, right? Are we at time? Okay, let's actually switch. So what I'm going to do is introduce my friend. This is Keeb. Keeb's going to come up, and he's just going to give you a demo of Swamp. You can find us later, and I'll show you like how we develop Swamp, and how that flow actually works, and the plan loop, and issues. I got so many things to say. But Keeb is going to show you Swamp. Do you want me to just plug you in?
No, you keep it there.
Oh, too late.
You can both? No, I got this one, it's fine.
But
Hey,
you gotta use this one.
Yeah.
here we go.
I got you.
Okay.
I'm like your AV guy.
You get a terminal ready for me?
Yeah, I'm going to do it.
Yeah. All right, does anyone in here have a home lab by any chance? Okay. And who's heard of Proxmox? Okay, yeah, the room, right? So maybe like you, I have some friends, they ask things from me like Minecraft servers to run on this home lab. And so I build it for them. And they run on a Proxmox server. And every other week I get a request for something new, maybe to make some changes, install new mod packs, start a new server, whatever.
I'm going to hold the mic so you can type.
Okay. Yeah, so what do? I do what you probably do at your job. I get a request. I have some idea how to service the request, and then I get to work. Sometimes I get distracted. And so this project Adam just talked about, Swamp, sounds interesting. But I like to put things to the test, you know? At the heart of things, the reason why I have a home lab is because I love to fuck around with technology. I like to take interesting ideas that I hear at conference talks, and I like to put them to use. So, you know, can Swamp actually build automation to help me manage this problem that I have with my friends? Can it actually discover what I have running and maybe make some suggestions about what I might want to do? You know, to set the table, Swamp is 3 days old, doesn't know anything about my environment, doesn't know anything about Proxmox. It doesn't know anything about the concept of discovery, which is to take resources that are actually running, import them into my infrastructure or my automation, and then do something or build workflows on top of it. And so yeah, here's how it went. So I'm gonna actually SSH into this home lab by first jumping through to the public internet, to my home. Okay, here I am. And yeah, so here's where we started, okay? Empty repo. Swamp has no Proxmox support. I said, hey, I have Proxmox running over here. Build what you need in order for me to be able to interact with it, okay? So it looked at the Swamp source code. It looked at existing models, and what it did is it built an extension model to Swamp itself, okay? This is like building a Terraform module for you or provider for you to be able to start automating some infrastructure. And it hit limitations. So what did it do? It modified Swamp itself and adapted, okay? And then I did things like, okay, now that you can authenticate and look at the state of my Proxmox cluster, maybe what I want to do is look at some VMs. Maybe what I want to do is maybe start one, okay? And so, yeah, the agent didn't pre-build anything. It extended Swamp. It extended the model as it needed, built authentication, built the ability to get things like VMs, and then we just vibed. Okay, so this is what it looked like, okay? So I had the user request to describe some infrastructure. It started with an empty thing. We started with a plan. We created the extension model, you know, built the code for me. We built the vaults and the credential stuff. We hit some limitations. It adapted. Then we did a full infrastructure scan, ran the scan, extended it as needed, and you know, here's the summary of what it built. Okay, so then next. Now, here I have Cloud Code, and now I can ask questions about my infrastructure. So analyze my Proxmox infrastructure, and maybe give me some suggestions about things I might change.
How long did it take you to do this, Keeb?
About 10 minutes.
10 minutes. How long would it take you to write a Proxmox provider for Terraform? The room laughed. I just want that to be just for the record.
Yeah, 10 minutes. Like I did this last night, you know, after being severely jet lagged, waking up at 2 a.m. I was like, this is a problem that might be interesting. So let me see if I can put it to the test, okay? And here's what's going to happen. It uses that entire workflow that it built in 10 minutes, and it's going to analyze all of the VMs that I have running, and then make a suggestion about maybe some things that I might need to change. Okay, so here we go. Right? It's got the name, it's got the CPU that I'm running, so that 14% load, I'm using 50% of my RAM, it's been up for 20 days. Here's the storage, this is true, I have a SAM amount for my ISOs. Here's the 3 servers that I'm running. Any Terraria players out there played Calamity? Super fun. Or modern Minecraft. Anyway, yeah, and then maybe there's some ideas here. Like, hey, you're kind of overcommitting. VM 102, what the hell is going on there? These are things that I might be able to optimize for myself. Okay, so now all this is read-only, right? Wouldn't it be really interesting if I could start to service my friends' requests and maybe, I don't know, create some VMs and operate them? And so here's the plan about how Swamp will extend itself in order to add VM create, start, stop, delete, basic CRUD stuff into the model. So what is it going to do? It's going to extend the input schema. Then it's going to add a task polling thing. So because the way that Proxmox works is you say, hey, start this thing, and it gives you a PID back and polls until it's done. It's going to implement create VM, right? Start VM, stop VM, delete VM, and there you go. So now I hit enter. I've reviewed this plan beforehand, and in about 5 minutes, I'm going to have full automation of Proxmox to create, delete, update, start, stop VMs. There you go.
There you go.
That's it.
All right, I'm going to steal this back.
Send me your order again by email, and then you get a button at the bottom to modify, and then you can modify your workshop that you want. We also have a women's lunch, but Carol will be talking more about that.
Hi everyone, if you signed up for women's lunch, or even if you didn't but would like to join, I have vouchers for that, and we have signs in the cafeteria with CfgMgmtCamp on 3 tables that is reserved for us. So come look for me. There are also some vouchers at 3 or 4 of the booths, but yeah, just come look for me, and I'll be already stationed there at those tables before lunchtime. You can, if you get a voucher, go ahead and get it on. Thanks.
So we have Ignite coming up. The first thing I need to fix is make sure that this machine doesn't end up without its power, because otherwise it's not going to be fun.
Oké. Moet je die wel gebruiken met de gasten?
Couldn't see Adam's talk. Why not? Iets met een klant en
thinks you have to sit in front here. No, no, here. Yeah, whatever. Who's giving an ignite? I'm looking for. No. Sure.
Werkt die? Werkt die?
Who's never seen an ignite before? Francis. Francis, stop explaining. Yes, you.
That's how you get a room quiet, actually. Everybody's good for chatting. We have the ignites now. The ignites are the fun factor form of the conference. So, bunch of speakers who are ready enough to send me 20 slides. They're going to get 5 minutes. They're going to be auto forwarding. If you don't agree with what they're saying, it's only 5 minutes. Where's James? James ran away. Oh, James is hiding in the back. I think we have more Ignite speakers that should be queuing up right there. I think we have more than 4 today. If they don't show up, too bad for them. But let's get this going, because actually I'm so stupid to do an Ignite myself today. And I just want to talk today about just enough container orchestration.
Are you the first one? Second, your first one? Yeah, you have to use this one.
Then we need to fix this thing. So for those who don't know, my name is Chris. I've started this conference together with.
Yeah, and if you are ready, can you pass it to the next one?
Sure. Crazy ideas. People always stress at me when their DNS is broken. I'm sorry. DNS, for those who still don't know, is DevOps needs sushi. And that's basically Shaper's great problem. So what is the thing? Containers are here to stay. If you think containers are going to go away like AI is going to go away, nah. Problem is, how do we deploy them? We've come to a point where people don't package software anymore. People just ship a Docker Compose file. Well, no, we even stopped doing that. Nomad has gone proprietary, so we're screwed there. We don't have a solution there. So Kubernetes is the only option we have. Like, Kubernetes is awesome if you have the right use case for it, but it's for a lot of organizations way too complex to manage. If you deal with the average enterprise, they have no clue what they're doing. And you know what? Not everybody needs to be doing distributed computing. Do they even teach that class here? I don't think they even teach it. I spoke to a bunch of people in different universities, and they had distributed computing as the last year master's class. Yet we want to have everybody play with it. So what do we really need? What do we really need is something that's lightweight, something that can do simple container deployments, that doesn't do complex networking, storage, and all those things. Basically, you want to take a Helm chart and throw it at something, and it should work. And that's all you need for a lot of systems. You don't want that complexity. So that's kind of the thing I told James like
8, 9 years ago, like, you have MGMT, what about if you just build this? And then MGMT is going, it's event-driven, it's idempotent, it's distributed, but it's simple, and it works. So, where is the code? Why didn't we build it yet? Hey, MGMT is awesome. Who's using MGMT?
And some other people that are not here.
Someone else, James. We all know James. He's a great guy. Puts up pictures of the shining me in every single slide, so it was time for a little payback. This is James, and James is stubborn. So what did I do? I asked Claude. I asked Claude. And Claude actually built this thing for me in like half an hour. And it works. So, just enough container orchestration is a really small thing that mimics everything that I needed from a Kubernetes API. And I just deploy a deployment, a service, whatever, and I throw it at that daemon. And this is what it does. It launches and it creates a bunch of MCL files. Those MCL files, they spin up a container. They expose the network stuff. And they do the little things that I want. This is actually an example in a test scenario where you just spin up a small little thing. I didn't do anything to get this working. Just ask Claude, build me this. And it generates MCL. Now the problem with generating MCL is there's not a lot of examples out there. So yeah. I now have a really small system that can deploy a couple of containers and it works. Is this something I want to keep on building? No. But I think a bunch of people who have more time on their hands can actually contribute and spin up things with this and go forward from this. And actually, I know there's people in the audience that already are talking about building similar things. So what is not something that I'm maintaining, but this is something that actually triggers James to start building useful stuff with MGMT. And now you can say something, James, if you really want to.
So it's true. We're actually going to show a pure MCL container orchestrator tomorrow in the MGMT talk that Andrew Clay is going to be demoing. And today at 4 p.m., I'm going to show some even fancier stuff of real-world magic, role deployments, etc. So thank you, Chris.
What's your name?
Okay. Is it good? Okay. Yeah, perfect. Welcome, everyone. So, who uses Kubernetes on production here? Half, maybe more than half. And GitOps? Almost the same. So, my name is Koray. I work for a company called CfgMgmtCamp, and I do consultancy stuff mostly. I do also some community stuff. I'm CNCF and platform engineering ambassador. I also do DevOps days and KCD Istanbul things. So this is something that you most probably at least once had in your life with a deployment or something on your CI/CD pipeline. But hopefully GitOps suggests a fix to that, and with this promise being declarative, versioned and immutable, pulled automatically, and continuous reconciliation, things are should be better. But yeah, I'll talk about some prides here. The first one is I'll talk about some sins, and the first one is pride, and it's about thinking that we know better than the system. So if you believe that your Git repo always reflects the production, that might be wrong, because there could be some some people might be doing some ad hoc changes. but then you should always monitor and you should always monitor for drift and get action on it. The second one is envy, just blindly copying other GitOps setups. Some organization might have a very beautiful setup for themselves, but you should always think about your organization, your needs. You should not copy everything and try it, but instead start simple with your own setup and then adopt new changes. The third one is sloth, or ignoring the reconciliation errors. So observability monitoring, this is not optional, you have to have it. And you should not ignore any reconciliation errors. You should act on it, fix them as soon as possible. Otherwise, things will be piled up and probably will there will be a bigger problems in the future. So alerting, observability, you have to have all the time. Wrath, or blaming GitOps for non-GitOps problems. So we are all resistant to change, especially if you are now going cloud native or implementing GitOps, Kubernetes. It's mostly easy to blame GitOps or the new tools, but the important part is that everyone in the company or who uses those systems should know how it works, understand how it works, and act on it. Last, or obsessive feature chasing, I think this is a problem for all of us, for all type of things. It's good to follow the recent changes, recent tools, but you also be careful about what to do or what to implement on your organization. If you don't need it, then maybe just try it out, but don't go to production right away because, yeah, it will create some other problems. Other sin is gluttony, or one repo to rule them all. So for your GitOps, especially for GitOps at scale, you might have issues having all the application code and the configuration into one repo. Argo CD also has some documentation for it regarding the monorepo. So try to have multi-repo strategy, make systems away from each other. And the last one is greed, or hoarding knowledge. Well, the whole DevOps thing is about, I believe, sharing the knowledge, understanding what's happening where or on which step. So documentation, knowledge sharing sessions, guilds in a organization, meetups, those are all important, and you have to make sure that everyone in the organization understands what's happening. So key takeaways, GitOps is not a discipline. It's a discipline, not a tool choice. You can use whatever you want. You should always watch for drift. Observability is not optional. Simplicity is more important than complexity. And you should not ignore the reconciliation errors. Thank you very much. I had this talk with my friend Jansu for GitOpsCon initially, so I also wanted to give her credit. Yeah, you can reach out to me if you like. I'll be around. Thank you.
Can I use this? Sure. Thank you. Yes. Oh, box you, yes. You ready? I think so. Good luck. Hello. My name is Sebastian. I'm a main developer of OpenVoxU. I'm working at ServiceERP as a cloud engineer. And why I started OpenVoxU was I wanted a single binary replacement for Puppet board. And we showed the first version on VoxConf last year. And the main issue I had with Puppet boards was Python. Something from OpenVoxU, we have queries in Puppet board, you can have one query, you can execute one query. If you want to do another query, you have to duplicate your tab or anything like this. In OpenVoxU, we updated it to you can have multiple queries. The query you have history of queries. You have predefined queries for frequently queries. So it's much easier. Looking into predefined queries are in the configuration. You can define them easily and look into rerun them from the UI without problems. You also have the query history. It's in-memory database, which queries are executed, so you can rerun them. You can adjust them, and so on. It's a nicely thing. And really new are query parameters. Query parameters are, you have the problem, you have your Puppet code and copy your PQL query from your editor to your Puppet board, OpenVoxU. Then you have to replace your string interpolated variables, and then you have to adjust it. You have to copy it back. You have to replace again with your variables. It's an annoying task. So in the last week, I thought, hey, let's recognize variables, provide some input fields, and render a new query, so you can you don't have to replace the variables every time. You can also have predefined views. Predefined views are in config like the predefined queries. You can have an inventory view. You can have a view of your broken nodes or something like this. It's really easy. Also, we developed a Puppet module for this to easy deployment. 3 lines of Puppet code, and you have an OpenVoxU running. Some people asked for documentation, so I added documentation. Not a developer thing. And last Friday we released 1.0 and get to production ready. So if you want to use it, use it. If you find issues, create issues, pull requests, everything is welcome. The next ideas of OpenVoxU are maybe PQL syntax highlighting and completion. It's nice to look in long queries and see highlights and things like this. A dependency graph is an idea between catalogs or between resources in catalogs. It's not an easy task, but we want to add it somehow like in Puppet Enterprise 2018. And we want to update our query parameters to save the query with the variables in it. Currently, we save the rendered query, but we want to save the query with the parameters in it. Also, for the predefined queries, we want to do the same thing, so you can rerun them and have only adjust the values of the parameters. It's a nice, helpful thing, I think, and maybe someone use it. Some great ideas in development was a member of this audience put a pull request at a dependabot. Nice idea, clean project, everything is fine. But this is a TypeScript, JavaScript thing. And NPM has every day a new, a new version of any library. So you have to much to do with a dependabot on a TypeScript JavaScript project. Yeah. Thank you for your attention. Feel free to contact me, contribute. Thank you. This. When's this? You ready?
Almost.
Yeah.
question. Hi, my name is Alfonso, working for a company called DEFA, working with electrical charger. I submitted this talk like a couple of months ago, talk about how you build a more effective engineering team with processes, standardization, and everything around that. But I changed my mind because that's not what you need anymore. So much has happened in the last couple of months, as I see it, and this is because of AI. What I've seen is an explosion with AI. It's changed completely how you work, how you do things, like Adam was talking about before. And this has happened like during the 6 last months, or 7 maybe now. People talk about 6 last months for a couple of months. This was Bill Gates. He was on a Swedish television show a couple of days ago. He's like a programmer. He's liked to program. Even when he was CEO, he was programming. He said that, I'm pretty impressed what the AI got much better. He's focused on AI now. He's not doing very much of coding that he did before. So what AI will do, instead of having a team that is 10 times faster, it will be 100 times faster. And I think Adam showed it very well. This is a real change that is happening now. A year ago for us at my company, we started to use AI, ChatGPT and tools like that. We saw like a 25% increase in performance. I was like Adam saying that AI was nothing, it will not change anything, dramatically just a tool. Today, I would say it's really increased the performance, at least within our company, between 200 and 1,000%. Adam was doing even more within this company, but this is what we have seen already now. For example, we set up like a AWS core setup according by the book and everything with Bloomy script. I would estimate it would take 6 months to do that. ChatGPT estimated 4 to 8 months. It took like 4 weeks to do that setup. We have created an in-house tool now. We did it in 2 weeks. ChatGPT estimated to 4 to 7 months. Actually, it was me doing most of it, and it was in Java. I haven't programmed in Java for like 10 years or something like that, so it will take even more. So we put like user stories like this. This is from Jira. We just copy it from Jira, put it in Codex or open code, and then the output a couple of minutes later was like this. It was like whatever we asked for or what we would like to have. This was like a simple task, and we already defined like the architecture and everything around it. So it was just super simple. So we did it like in 5 minutes. And this would have taken like 1 day or something like that. And I work on a hobby project as well, together with a friend. We have spent like 6 weeks. We have made like 50,000 lines of code, complicated microservice setup and everything. It was estimated to take between 12 and 24, 1 to 2 years. This is a merge request that my friend did. If you read in the bottom, you see he changed like 258 files, 13,000 lines of code was added, 11,000 lines of code was deleted because it was the refactorization, and he did it in 2 days. So this is where my computing career started, with a ZX88, if anyone remember that, it's old enough, 1 kilobyte of memory. This was like the first major thing within computing for me. And actually, I wrote like the program to the left is the program I wrote. You print it on a type print. I was actually selling it in classified heights. And if you find it, it was generated now. It was called Airfight, after an airfighter in Sweden, Viggen. There's a bug in this code. If you find it, you can contact me. Then the next major thing for me was like internet, where you start with FTP, SMTP, Gopher, if anyone remember that one. That was before Netscape and Mosaic. This was like the major thing in my computing career. And now is the third major thing. It's the AI coding agents, like Cloud Code, Open Code, Codex, and things like that. When you create plans, and it creates the code for you. I haven't seen something like this in since the 90s. Where are we going now? This is Santa Maria Columbus going to US. They didn't know where they would go. We don't know where we go. How will it end up? Or will it end up with Trump, like in the US ended up? we don't know, but a lot of things were changing, as Adam pointed out before. So I would say stop write code, create code instead. That is the future. Then I would like to do some raising hands. Everyone that has used ChatGPT can raise the hand. Have you put some in production code from ChatGPT? Keep your hands. Okay, good. Have you used tools like Codex, Claude? Keep your hands. Okay, have you put something in production from them? Good. I think you're quite work safe for in 1 or 2 years for now. The other of you, I think, have to change your mind and start to use those tools because you will be out of job. Thank you.
Who's next? Is me?
Yeah.
Oh.
Due microfoni. This is not.
Yeah, you can also hold it.
You can use both. I can use. Anyway.
You ready?
I'm here. So this is going to be interesting for who is using Puppet. I think also who is using Ansible. This is about Pabawi, a class infrastructure command and control tool, which I did, Alessandro Franceschi, from example 42 in the last 2 months. So what it is now, a web interface for Puppet, Bolt, PuppetDB, Puppet Server, and Hira. You can easily activate integrations and basically visualize on web whatever makes sense to visualize with this kind of integrations. So, for example, inventory listing with PuppetDB or via Bolt, execution of commands via Bolt, Hira lookup of the keys used in the code and code-based analysis with the Hira plugin, future integrations with Ansible or any kind of similar tools. The tool is self-explanatory in terms of how to configure it. You have a page for setup for every integration. It's quite easy to set up in an existing infrastructure. And you run it on your machine. The current version is supposed to be run locally, and to see what you can see from, for example, the inventory of PuppetDB, in this case also Bolt nodes, so a list of nodes in your infrastructure. This tool is for the classic infrastructure, good old VMs and physical servers, if you still use it. What you can get, of course, whatever information you can get from tools like PuppetDB on a node detail page, with relevant information. You can see any kind of stuff which is available on PuppetDB. So facts, Puppet facts, of course, are visible in different ways. The point is that you can also do a global search for facts to see how some values are present in your infrastructure. That's the next slide, but I am anticipating times. The whole idea is also that you can get from PuppetDB reports, of course, of Puppet runs. So you have a visibility of front end, a new front end for Puppet reports, see what is happening, what is changing, when it changes, details on the specific reports, details of the events. So what has changed in Puppet world, in this case, a single file change in the last Puppet run. And of course, this is all coming from PuppetDB, all available, nicely visualized, shown. On PuppetDB, we can also have the full list of managed resources by Puppet. So useful to have, nice to see, nice to know what you are currently managing with your Puppet tool on your system. As well, you can have a lot of information about your infrastructure facts. So interesting, see all the IPs of your nodes, see all the domains of the operating system, whatever is written in a fact can be easily, especially quickly visualized in this web interface. You have the integration with Bolt, so a web frontend to execute Bolt things. The list of execution done, when, on which machine, the status of the execution, and of course for each execution, the detail page where you see what happened. In case of Bolt, there is also automatic discovery of the tasks available and the relevant parameters. So you don't need to configure anything. You have already the interface to put the right values in your, for the parameters of the task you use. For every execution, you have, of course, the detail page with what has happened. This is now working with Bolt. Future plan is to make it work in the same way with Ansible. So basically a web interface to the commands you run on the infrastructure. You can have, with the higher integration, also the analysis of the Puppet code. Basically, if you have, you can see what are the classes most used, what are the classes not used, if there are some links in the code to fix, if there are Puppet modules to update in your Puppet file. The code analysis does this. And there is also the area integration, which allows you to look up hierarchies, how they are evaluated in your node. So for a given node, you can see what are the values of the hierarchies and where they are set in what part of the hierarchy, which is useful for understanding what hierarchy does. And also you can do a site-wide hierarchy lookup, so understand the values for some specific keys in all your nodes. So you have this kind of information available with the hierarchy integration. Last but not least, you can do catalog diff. So compare two catalogs using two different Puppet environments of two different branches of your code, see what are the resources different, and so have a sort of preview of what Puppet will do on your system before changing it. Needless to say, this was done in 2 months, but not by me only. There was also my friend Claude and his own friends. Version 1 is under work. Actually started it 2 days ago. There is a lot to do, but I plan to do a full integrable, pluginable plugin system. Tomorrow I'm going to talk about this. Room B after lunch. Be there if you want. If you're interested in look at it, I can demo it, I can show it. I can also install it quickly in 15 minutes in your Puppet setup because it's very easy to set up. Thank you, everybody. Oh, yes.
I think I also need this. Can you help me with this? I don't get this. Like this. See, it's annoying. All right, let's do it. Hello, my name is Yair, and I'm most likely one of the oldest people around here. I've been doing systems and operations since the early 90s. I started actually with VAX VMS. I actually was working with OS2, if anybody in this room even have a remote idea what I'm talking about. I remember when there was no internet. And then there was Unix for me. I was falling in love with Unix systems design and Solaris. We ran containers in Solaris. It never failed us. I was mainly enjoying, and we know Unix has one thing. Do one thing, do it well. So it kind of stuck with me. I kind of like it. But I think we also kind of forgot this thing. And then time flew. I worked as a quality assurance engineer for quite known brands. Then I did some other things. Had the pleasure of working with a lot of this open source community where I lived in Israel and then Berlin. And then became a consultant, manager of a company. Fell in love with DevOps. And then I had a kid a year ago. And I don't know what happened, but I wanted to do my own thing. Like just one tool to check how it goes right now. Started like a pet project. It was just a CLI, very simple. And I tried to use the tools we have now, and I really weren't enjoying anything that was happening around me. Yes, I'm gonna wait for the next slide. First Ignite, so like I say to everybody, Kubernetes is brilliant, yes? It solves Google's problems. I'm just one person. I have no ability to deal with this monstrous thing. And also from work, I don't like Kubernetes. I spent 5 years telling people not to do Kubernetes. All the simple tasks require complex infrastructure. What about simplicity? I just want read open telemetry. I don't want to deploy a whole backend called Jaeger with a lot of databases. I want simple tools because I'm a simple person. Yeah, I'm a simpleton. I want easy to use, easy to maintain. Please, no YAML. I hate YAML. I despise YAML. So I built what I needed. And that's the magic where it comes to what Adam was talking about. Apparently, Cloud Code started really for me. It was just basically doing bad shit. But now, I learned how to work with it. And the first tool I created is called Cykli, or Cycli if you read it like this. All the names are in Finnish. It's a CI that is basically works locally and first local. So at last, we can use our M4 processors. It has SDKs for Rust, Go, TypeScript, Elixir. There's no YAML, no DSL. Where's James? It's built on Beam, so it has concurrency of Beam. And it works remotely and locally the same. I use it for all my projects. Now I also did Nopia, another Finnish name. It's GitOps. It's written in Elixir. I don't know Elixir. There's no Redis, no Cassandra, no service mesh. It's just one dependency, and it also does CD events. It watches the repo. It syncs the state to your cluster. OK, it has CRD one, but there's no Redis and no Cassandra. It's the old one. I'm mega dyslexic, so I sometimes don't see stuff. The thing is this. Yes, I agree. This comes from vanity and frustration. But it also comes from the idea of Unix infused with what I really like about DevOps. And it's amazing that we can do all these things now. I created so many tools. And they work, like there's Kulta, Seppo, Polku, Ilmari, Rauta. They're all trying to do one thing and do it well. So I think with the new things that we can see around us, we have the power to do a lot of great stuff. I even got really, one night couldn't sleep, and I have now my own programming language. I don't want to talk about it too much, but if you want to talk about it, catch me somewhere. It's my own programming language. It's compiling to itself soon. These tools are not in production. I wouldn't use them in production. But Cycli works. It does what it needs to do. And I started in June, and now I have 12 tools, maybe a startup that I'm starting. And that's it, basically. And I'm saying we can use these tools to go back to the Unix way and not do Kubernetes. Okay.
Who's hungry? Probably saloon here.
Thank you.
We'll sign in at 2.
there's an Anthropic outage.
Oh, that's interesting.
Is there actually? No, it's not. He's a very good.
That would be interesting. I maybe can switch them back to something else, but.
Okay. Hello, everybody. Welcome back after lunch. I hope you had a lovely lunch. I'm in this room all afternoon. There's a lot of interesting talks. Firstly, first talk up, I'd like to introduce Marcel from ATComputing. Marcel's going to actually try and build an enterprise-grade app in 30 minutes using GenAI, which I think is an incredibly lofty goal, so I'm excited to see it. Please welcome him.
Thank you all. Yeah, I'm really looking forward to it as well because I have no idea what will happen. And that's frightening and exciting at the same time. So, just as mentioned, my name is Marcel Kornegor. I'm a director and co-owner of ATComputing, which has been a long-term sponsor of CfgMgmtCamp. We are here since the first edition, I believe. And besides my daily work as a director, I like to fiddle around with tech. So I say I'm a nerd by night. And this has been some project that had got out of hand a bit. And that's why I submitted the CFP. Say, well, I have some interesting findings that I would like to share with a bigger audience. So hopefully I will take you along my journey and you will learn a ton and we will have some fun along the way. So yeah. AI is all over the place. It's well, today here, it's not like the ultimate buzzword, but if you look at conferences, it's a huge topic. So I've used it quite a lot in my daily work as well in the meantime, and I think it's as terrifying as it is amazing, so it's a bit of both worlds. And also, lately I've done more and more coding with GenAI, and that brought me, of course, in the vibe coding space, where you use GenAI to generate code, and that popped a lot of questions in my mind, like how far does this go and what are some boundaries? And I've seen on YouTube a video from a guy that actually deployed a web application within 30 minutes and got it working. But that was more like some SaaS-based application. So the platform, etc., was already running and it was just writing the application code and deploying the application, but the infrastructure was already there. And I thought, well, that's great, but in like a real enterprise situation, you also have to think about all the infrastructure and configuration parts. Would it be possible to do all of that as well within 30 minutes? So I raised the bar, you can say. I got a bit more confident when you look at how quickly the GenAI models and tools are evolving and are becoming better. So if you asked me this a year ago, I would start laughing like, well, that's impossible, it's not going to happen. But there is a lot of progress made in a short time. So I had this research question like, is it possible? So how good is it in creating an actual app? So that's the goal of today. Let's find out. And the challenge will be, can GenAI write an enterprise-grade web app within 30 minutes? There's nothing running at this point, so there is no infrastructure, there are no servers, there are no containers yet. Completely like a blank canvas. Can it do it? So let's first have the definition of what is an enterprise-grade app anyway. I'm not going to read like all the lines, but there are some architectural demands or some features it should have. So it should be secure, it should be scalable, highly available. You can read it. So these are some boundaries. So this needs to be fulfilled. But there's more because you want to also maintain it after the launch. It's like day 2 operations, so there should be some form of monitoring and observability in place. There should also be testing in place so that you can troubleshoot in a nice way. Also, of course, compliance and governance, so it should be reproducible and it should be codified so it's auditable. And the list is even longer because you might want to have some form of resilience. It should be extendable. Also data integrity and also data encryption should be in place. So this is quite a long list, and I'm not going to argue if it's complete or it's missing something, but this is more than just an average app you're producing on a Sunday afternoon when you're fiddling with some code. So, can this be done? No, it can't. It's impossible to do this all within 30 minutes. So, if you're disappointed, you can leave the room. Talk finished, bye-bye. But why is this not truly possible? Does this have to do with the vibe coding part, or is there something else that's keeping this from happening? And that's what I found out like along the journey. So I had this idea some time ago, like, this could be interesting. So I started my journey, and I started to visualize the goal. So what do I want to achieve? And what tools am I going to use? Because there's quite a lot of tools, and I will get back to that in a bit. Also, what functionality should it feature? So what are you going to build? What's the idea behind the application? And what level of detail should it have? So I already mentioned it should be enterprise grade, but what is that exactly? So the definition I have come up with is been part of the process of designing this app in my mind or for this presentation. And also I thought, like, well, what shortcuts can I allow to have? So where is the boundary of this should be there or this shouldn't be there? Like, should it also have this big API for connecting with other environments, or should it be standalone? That kind of boundaries is all what I've been considering for this talk. So I was driving along my journey in my car, and it was quite fun because the most fun thing for me about speaking on conferences is the journey that need to be resolved as prerequisites before you can actually start to write a line of code. And that's I've tried it, so I've tried this in a dry run, and it's impossible to answer like all these questions within this given time. It's just too much. There needs to be too much in place already before AI can start to write code. You need to make a lot of decisions. You need to have a lot of choices. What tool stack? What does it need to be left or right or big or small? That kind of stuff. It's a lot of variables that that are required. So. Yeah, prerequisite, the architecture, you need to think about variables. So how am I going to control this application after it's running or during bootstrapping? What design should it have, which also means what tools do you want to use for the application? Also within a real-life company, there will be a lot of opinions and a lot of politics in place because different teams will have different views on what's the best way forward for the app. Well, I'm a one-man army, so that's an easy discussion, but I also had to think a lot about how do I see this for me. So as with my architect hat on, to see what do I want the app to be and how does it need to work. So, and also in a real-life situation, you have a lot of brownfield, and now I have this clean sheet, so there is no legacy, but in real life, if you're going to vibe code an application, it might be that you're stuck to some platform that's already there with some legacy configuration that you need to comply with because of auditors or other regulations. So this is a lot of stuff that does not have to do with writing code, but it's all required to be able to write the correct code. So this is vibe coding to me now. It sounds really good. It's really great for small projects, but if you want to scale it, there is a lot of stuff that you need to know or you need to decide before actually starting to write code. So I'm still in my boat, still looking at the vibe coding part, but have now learned and experienced that there is more work underwater than actually writing the code for the infrastructure or the application. But that also was a starting point for a lot of fun, because when I realized that this was the case, I have rescheduled my preparation and said, well, I want to show something here on stage that's doing something and not saying after a half an hour, we now have our requirements and have a nice day. So I have done all the preparation before the talk. And that is quite, quite something. And I have not written anything, well, almost nothing of this either. So let's see, this is visible. I've created a lot of markdown files just for ease of rendering. And this is all like the project requirements. So I've discussed with ChatGPT and with Cloud Code on the network architecture, on the project setup. So what's the goal of the application? What's the requirements? I've done this also for like the database part. What database to use? What's the requirements there? How can you set it up? And I've done this only by prompting. So just saying, I have this idea about this application, guide me through everything you need to know to make sure that I have the right requirements, and write all these requirements to something that you understand to be able to implement later. So I explicitly said, do not write any code, just document it and make sure that you can use it later on. A combination of ChatGPT and Cloud Code, yeah. So this is really a long list of all the topics, all the requirements that you need to consider before writing the actual application. And the most interesting thing is that after all this was done and complete, I said, now, based on all this documentation, create an implementation plan. And I can make it a bit bigger. So I've just said, I want to create an AT computing swag shop which sells products, so a web shop for our company. And this is the whole implementation plan. And it's really long because there's really a lot of stuff that needs to be in place to get this app running, because it's an enterprise-grade app. So Cloud Code wrote around 3,000 lines of implementation implementation plan with a lot of checks. So hopefully I can just say, start writing phase 1, and if you're finished, let's check and go to phase B, etc., etc. But in the end, it's quite a long list of stuff that Cloud Code is going to do for me, hopefully. But this has been done all before writing a single line of functional code. But as you can see, this is already an application or an architecture framework, if you like. Also, I asked Cloud Code to create a file called variables.md to keep track of all the variables that needs to be in place to get this thing up and running. Because I want to run it somewhere, so I need some platform. And to deploy it, I want to use OpenTofu that needs some credentials on the API to do so. So that means that there need to be like passwords, tokens, API keys in place to get this started. And this is what I've done in the GitLab repo. So let's see if this also works. Yep, this should work. Okie doke. Up. There we go. I thought I had this already here. There we go. So in this, this is my Git repo, and I have my. There's no code in the repo yet. It's only like the presentation and all these markdown files. But there is a lot of variables in place, so I predefined all the variables that Cloud Code has suggested me to create. So I have not reviewed it, just said, give me what you need, and I will configure it and make sure that it's there. So I also configured Stripe checkout. So there is this checkout key. I configured an SMTP entry in our Google Workspace environment. So the application will be able to send mail on behalf of AT Computing. And that's all like the prerequisites, all the boilerplating that was required to get this app up and running. So as you can see, it's quite a long list of different variables. Some are secret, some are public, to make sure that, to hope that Cloud Code will be able to produce something that's working. Yes. So as you can see, this is quite a lot of work beforehand, and it's impossible to do this here live on stage within half an hour, because I cannot configure an SMTP authentication and Stripe connectivity, and I'm using a cloud platform which we'll be looking at a bit later. That's also configured, and there's this API key, etc. It's just too much. You cannot do it within 30 minutes. So. What's left to do then now for Cloud Code to do? When I had everything in place, I just said, okay, do an estimate of the work that needs to be done to get the app up and running. And this is the estimate that Cloud Code gave. So I need to create, Cloud Code said, I need to create 126 files with 8,500 lines of code, and that should get you up and running. So hopefully, by the end of this session, we will have this done, which would be quite impressive. I'm not sure who the programmers here are, but writing this within 30 minutes, it's quite ambitious. So we have seen this picture, and hopefully now it gets a bit clear why the coding part seems to be a small piece of the whole puzzle. But be aware, the coding itself is also an onion that has a lot of layers because, well, I'm not an experienced or seasoned programmer, but if you go into programming, you will dive into a different world with different challenges, which can be the same thing again. So it's like from one loophole to the other, but that's a bit out of scope. I will just say happy to Cloud Code. This is your onion, this is your problem. I'm not going to worry about it because I'm not going to write any code. Black box, yes, it's just Go. Black ops, yeah, it can be called that way as well. So, these are like the two and technology choices I've made for the application and the infrastructure. And I've chosen Exascale, which is a European, Swiss-based cloud platform. Why did I choose it? Well, first of all, we're European here, so that was a choice. And also because I've never used it, so that seemed like a nice challenge. I'm using OpenTofu for the provisioning of the infrastructure. So OpenTofu will interact with Exascale for the infrastructure. Ansible will be used for configuring the stuff that we have created in the cloud. Stripe for payment, as mentioned. The application itself will be a combination of Python with Flask and Bootstrap. So it will be open source, the whole open source stack, Postgres database, and I will use the default storage buckets within Exascale to store the product images that we're going to upload. So again, I will not write any code myself, and let's see if it will work. Yes, so this is a picture of the landscape. Nothing is running yet, but this is the goal to create. And I hope by the end of this session you can purchase this great AT Computing black cap. And it should, if everything works, be like a real checkout, and you will get an order confirmation, and I can hand it to you if you have paid the fee that's required. So let's hope it will work. That will be great. But otherwise, we have learned something or have had some fun. Yeah, disclaimer, I'm not sure what's going to happen, so I'm just using Cloud Code. I will give some prompts and get started, but I have no clue what's coming out of it. And I can also not predict what will happen. So maybe if Anthropic has this outage at this point in time, we will have to troubleshoot it because it's live. There is no fallback in place. So this is the prompt I started with, which was the question, how do I start this project? Do you have any idea how I can best provide a long and detailed prompt? Because there is quite a lot of prompting to do. But I'm just going to start with some prompting. All right, so let me launch Cloud. So I'm there. I hope it's readable. It will be a lot of text, I guess. I've prepared the design and requirements for a Python-based web application. You can find all details in the @5 directory. Start implementation by the checklist. It was /pipe and then /implementation. Ask me questions. Ask me for questions or input along the way. Good luck. Okay, so now we will burn some rainforest and have nuclear plants produce extra gigawatts because now the cloud is going to be heated up. And it will first start to investigate like the whole stuff. It already picked up that it's called the swag shop, so it has some work done already. And this will be doing a lot of investigation first. While it does so, I will switch back and forward to the presentation slides to give some, oh, it's already asking something. Do you want to proceed? I will just say yes and YOLO, just go. Yeah. this is quite important. Don't try this in production or don't try this at home, because it might be that it will delete the whole project. Well, that would be funny, but a bit sad. But you want to be careful if you're doing this with sensitive data, etc. So I know that my directory is completely clean of anything that's secret. So just go ahead. It may read everything and do everything. But now I've given my keys to the cloud and to some American big tech company. All right. What I've done as well is I've had a lot of experience with CI/CD pipelines in the past, where you have like 7 stages and 5 of them work perfectly, and it takes like quite some time to provide some resources. And by the end, it says, well, I cannot continue because there is some variable missing. So I've explicitly asked Cloud Code if it's going to write a pipeline file to have a first stage, which is like a takeoff checklist. So it will check if all things are in place before it continues in the pipeline. And I was a bit amazed that I have not seen this concept a lot in production environments at customers. So if you're running a CI/CD pipeline, I really have this tip. Make sure you have this pre-flight checklist stage, because it saves a lot of time, because you're not waiting for feedback on a variable that is missing. You're getting it right away, and it's really a time saver. So hopefully it will listen and will do it, but it's for now writing application core files. So it's already burning through tokens, and it's like boilerplating everything, creating files, etc. All right. Let's go back to the slides. Because I have some tips and tricks. So what I find is that if you're going to do this bigger project, it's really worth a while to spend a bit of time thinking how to approach it. Because that time will be saved later on, because these LLMs have the tendency to go like to the left when you don't want it, and that's mainly because you have not been specific enough. So if you're going to vibe code, this is my secret skill, where you have on the right total control of how everything works and everything should be, which is of course the architect of the matrix. And on the right you have like Belgium drunkenness, where you have a lot of delirium, and this is just YOLO, just do whatever you want to do, and we will see what happens. So if you're vibe coding for some proof of concept, you can be more to the right. That's fine, because it's just more creative and it's not too strict, and you get a lot of inspiration out of it. If you're going to vibe code for production, you should be more on the architect side and have a better definition of how it should be and what you want it to be, or how you want it to be developed. So for this project, I definitely was more on the left side. So I've done a lot of forework to make sure that it's going the direction I want it to be, because it might be, if I would just say create this application, that Cloud Code would choose to use JavaScript, which I might not like for my application landscape, for instance. So there is a lot of stuff that helps to make sure it gets the direction that you want it to go. And of course, be aware, there's this fog of hallucination. It will, within these bounds, still have some own adventures, because that's the way the LLMs work. It's just in the nature of the technology, and you need to be aware of it to make sure that it will not bite you, but will help you along the way. Okay, it's still coding, almost 20K tokens burned, and it's not prompting for anything, so it's now creating Flask blueprints, apparently. Let's get back to the slides and see how it proceeds. Okay, so this means that if you're going to do this project, it's really helpful to first create a plan, like an implementation plan, before you say start to write code. So that's what I've basically done. I've created all these documents and all these context to make sure that if it starts building, it will build the way I want it to be. So there is this boundary, this sandbox that has been defined before it actually starts to work on the workloads. And this really helps on decision making. This really helps for the model to keep track of what it's doing along the way. Because I've had, especially if you're using it like in the morning and you take a break and you close the session and continue in the afternoon, it's a clean sheet. So it does not know it has been doing something before. And this really helps to say, well, you've been vibe coding to 0.50, start at 51, and then it will continue. Well, it's not perfect, but it helps to make sure that it keeps track a long time. Also a tip, and I've done it not in this case, but for some prompts, it's really useful to give a system prompt. To make sure that it has the right mindset for the job that has to be done. So if you're going to use GenAI for troubleshooting, it might help to say that it's a veteran SRE and that it's tasked with investigating some critical error, and then the GenAI model will adapt to that assignment and have a different way of looking at the problem than when you say it's just a junior developer, for instance. This is what we have done already. So, what does this system prompt do? So, I have given the system prompt, you are a medical doctor specialized in leg trauma. That's what you are to Cloud Code. And next question was, what configuration management tool can I use to configure my VM in Exascale? So I first said you're a doctor, and then I ask an IT question. And Cloud Code is very smart. It responded, I'm Cloud Code. I'm an assistant for software engineering, not a medical doctor. So it's a good answer. ChatGPT was also smart, but some time ago it just gave an answer with like a joke in it, where it answered with Ansible for this job, but also gave a pun in the medical direction. So that was quite interesting. But you can see here that Cloud Code has specifically been trained for code development. So it's really, that's its purpose, and that's where it's good at. So let's see if it's still coding. Yeah, it does. It's creating HTML templates for our card in this case. So it's truly producing a web shop. And it's still going, so I will continue with the slides. So along the way, I got to some interesting quirks. Because AT computing has this blue color, which we have been using quite some time, and it's also everywhere on the website. So I want this web shop, of course, to be in the same style as our regular page. So I said, as part of the preparation to Cloud Code, I want you to get the color scheme of AT computing based on the website. So investigate and make sure that you catch it. So it asked me allowance to crawl the website, and afterwards it said, well, I found these results, which is hex code, so you are not required to understand it. But important is that the blue color of AT computing is totally different. So I have no clue where these colors came from, especially not when I directed it to the website where the correct colors are just in the CSS or the HTML. And this is quite interesting because it seems like a simple assignment, but it totally screwed it up where you would expect it to succeed. And I tried to correct it, like you've not done it right, do it again, and it just got stuck in strange colors. It was really, really fascinating. Also, this was fun. In the Netherlands, we have 21% VAT. But Exascale is a Swiss company, and during the chat in the preparation, I said that it was okay for the application to be running in Switzerland. So automatically, Cloud assumed that the webshop should have the Swiss VAT rate, which is 7.7%. But that was not what I've asked. It was just an assumption based on where it was running. So I really had to tell it, like, no, the hosting is different from where the application is operated. And then it needed to rewrite like all the code. Oh, I was stupid because I thought it was also Swiss VAT. And the fun thing is that some harder stuff that I say, well, I'm not sure how to code it. It will do it like flawlessly, but this kind of stuff is complicated, apparently. All right, so let's get back to the prompting. It says that something has been done. It created all the HTML templates, and now it's already busy writing some Terraform files, which will be used by OpenTofu, but it's the same structure, of course. So let's see what it's doing. Yeah, it's creating the OpenTofu modules. I'm going to have a look at the clock. Still have like 11 minutes. Woo! I'm really skeptical. So let's see. But it's a bit further, but still the provision needs to be done. All the configuration needs to be done. It needs to be running. I'm not sure if 11 minutes will be enough. So what my biggest takeaways from this project is that it's really doing more like the iceberg. So if you've done all the work under the water, it makes the actual work for the vibe coding a lot easier. But this really means that you need to have, I think, more like a system way of thinking, to see this application code not as just being Python, but as part of this whole ecosystem. Because an application does not run on air. Well, we call it the cloud, but it's actually just hardware. And you need to be aware of this whole ecosystem. So all the dependencies, all the things it needs to be there, to be running. And this really helps to make sure that you actually work towards some goal. And also, I found it really helpful to explicitly ask for the model to ask you questions. Because if you do, and this also helps to become the architect more, so more to the left on the scale, because it will otherwise will drift in a direction, and it might be that later on it will make decisions or ask you questions based on assumptions that are done in a previous stage. And that's something that's really hard to fix afterwards, but can be prevented if you say, well, if something is not clear for you to do, please ask for my help. And this results in making the checklist so that you have this strict structure that it needs to follow to complete the orders. All right. So it's, I think it's still quite impressive because it's working for 12 minutes now and it already has created a complete Python application, all the HTML files. It has created all the Terraform plans, and it has also created quite a lot of Ansible playbooks in the meantime with roles and everything. So I'm not sure what its hit rate on the keyboard is at the moment, but it's quite quick. So maybe I can see in the checklist if it's updating live. That would be great. No, not yet. Oh, I think it's not updating the app implementation right. It might be that it does afterwards when it thinks it's finished, that it will check all the boxes. It's just some markup. So in this whole plan, I will say, if you have done everything, test it as well. And this is like the checks to see if everything is in place. But this is just some markup it has added. Because GenAI loves emojis for some reason. So let's see. Oh, it's producing a lot of text. There's a question. I want to do something. Yes, that's okay. Because it also will be writing tests. And it needs to test it, obviously. Yeah. All right. So we have some minutes left. So I will be happy while this is running to answer some questions or shine some light on something. Or if there are some questions, please feel free to ask. Yes?
What's your thought on using this for, let's say, governmental projects?
I will repeat the question. So what's my thought or opinion on using this for a government project? Well, tomorrow we will be having like this roundtable discussion around sovereignty. I would not be really happy to use this American LLM-based approach for Dutch government data or any government that's not US from a privacy perspective. So although Cloud Code says it will not use your data to train, you have no control because it's black box. So no, I would not use this for the government. Well, I would strongly suggest to run a local LLM with some beefy hardware that is capable of doing these things on your own data set with your own secrets on your own premises. Well, that's not true, no. There are some truly powerful open source based models, but you need hardware. So you need a lot of processing power, a lot of memory to run it on par. But it's not impossible. I just don't have the budget to purchase like for $1 million of equipment to run it. But it is possible. Yep. There was another question? Yeah? Mm-hmm. Yeah, it's still subjective. So it might be that there's somebody that's really like doing magic with a local solution. And especially the Mac Studio is quite famous for being really powerful for bang for the bucks wise. And also there are a lot of models that might be really good at specific jobs. So it might be for your specific goal that a local model on your Mac Studio might run perfectly for what you're going to do. Also, if you have a lot of data on your local system that it can use as a reference or as a starting point, that hugely helps to make the sandbox. So after this conference, I'm going to use the same files that I've created with all the building blocks to see if I can also produce this with my local LLM. Because now I have like everything in place, and it's less a clean canvas. It's more filled out already. So maybe a less powerful model will be also creating something that's working. And this evolves rapidly. So it might be within a year that the hardware is better, the models are better, etc., etc. Not sure what the future will bring in this area. You had a question somewhere? No, I thought so. Yes. Yes, at the moment it's running internally because there are some secrets that I would not like to share with the world. But if this produces something interesting, I will upload it to my GitHub page. Yeah, and it will be publicly available, but it depends on what it will produce. So I will keep my laptop running after the session and see when it's finished. But because I don't think we have 3 minutes? No. My handle is Strobodov. Yeah. But I know ways to share it and other questions? Yes? Is there an equivalent to Cloud Code online for self-hosted? Yes. Yep. Yeah, so the question was, is there an equivalent for the Cloud Code command line interface? Open Code can do such things also for open LLMs. Yes. I think we can conclude that 30 minutes is too optimistic. I think that Cloud has done its best. In 18 minutes it has produced quite some stuff. It's still writing tests, I guess, PyTest. It created also the CI/CD pipeline file. That's interesting to have a look at. Let's see. Because it already produced some files, I guess. Here's the web shop. Where is the... Is it already there? I don't see it. Am I blind? Oh, here, yeah. So it created already quite some files. And here it created a pipeline file with the pre-flight check. So it did listen. And it created some variables. But as you can see, it's quite an extensive pipeline file as well, with, as far as I can see, a lot of things that make sense for this kind of deployment. So it's actually building the app, provisioning the infrastructure using OpenTofu. Yeah, so it's 500 lines-ish of pipeline code as well. It also does a SSL verification check. So it's working hard for us. All right. Oh, some questions. Yeah, I will ask them. We'll answer them in a bit, because it's yeah, it's time. So, my takeaway, hopefully it was, well, the result is a bit disappointing maybe because there was not enough time, but I'm not really surprised that happened. Hopefully the journey was interesting for you to see and how it's truly powerful to get this far. Please feel free, I'm here like the next couple of days. I will try to get this running without any code by myself. And if you have any question and see me, I will be happy to provide updates with how far it has proceeded. If you're going to do this, remember that the bigger your product, the bigger the preparation is. And that's really like the key takeaway, in my opinion, that this is really saving a lot of time and helping you to achieve your end results. Thank you.
Hello, hello, hello. That works. Yeah. Huh? Oh, no. I don't take your chocolate. I hope I get my own one. Oh, yes. Thank you very much. I take this stuff away here. Should it just start ahead? Okay.
Hi folks, we're going to get started with the second talk. I'd like to introduce Bernd, CEO at NetWays, co-founder of Ichinga, whatever you want to call it. Runs the best named conference in the world, StackConf. It is literally named after me.
Yeah, exactly.
Every time.
Yeah.
I'm excited to see you talk.
Thank you. Thank you very much. Good afternoon, everyone. So I hope in the next 40 minutes I can try to bring what I think about all these topics to you. Okay, this is not working at all. Perfect. So the disadvantage is talking about AI, that every day you have the feeling you have to update your talk. I created the talk early January. Even like today, I would like to update like 10 slides of it. The advantage is that most of the things in my slides are just assumptions, so it's not facts. It's just the thing, how I think it's going to be happen in the next 2-3 years. So probably if we meet again in 4 years from now, you can prove me wrong, or I was right, whatever. But so it's mainly what I think could happen and what are the influences. So like Paul said, Paul Stack, thank you. My name is Bernd. That's one of the tiny number of facts I have in the presentation. We have a booth with Ichinga in the coffee area, so if you're interested in enterprise monitoring, please swing by and talk to my colleagues, which are all here. I hope someone is at the booth. But anyway, take the chance to come over. So to set kind of a baseline what AI is for us, I don't know what AI is for you, but it's just to try to make some assumption what it is. For me, it's generally a new interface to knowledge. Because how it works, it's very fast in answering your stuff. It has very low friction, which is an advantage and a disadvantage in my opinion, but we come to that later. And it has a very high confidence in answering your question, but this is mainly the reason how AI is made. So fundamentally, I would say it's an impressive technology, and it's also impressive if you think about that the fundamental, what all the language models are built on, which is, this is the right title, Attention is All You Need, which is a Google paper, where also the name was really inspired by that Beatles song, is from 2017. So all the transformer technology, which is part of this, is just like 9 years old. And if some of you played with AI or ChatGPT or all the different things, perhaps 4 years ago, I think we could barely imagine what will be possible today, like looking at cloud and image generation, all the different things. So I think it's impossible to imagine what could be possible in 4 or 5 years from now. And I think nobody can, and especially also there's no linear development. It's going faster and faster all the time. It's just amazing. So it's an amazing time to be live as always. It writes config in seconds. It is very good in explaining logs, so going through big data and explaining you stuff. It's never tired, never annoyed, like a colleague you have. And it's pretty much cheaper than colleagues, which I don't know all over. This is true, how much money is wasted in that industry right now. But of course, it's way cheaper to give you a quick answer. So to make this clear also, this is not an anti-AI talk. So the technology is great. And using the technology is absolutely not a problem. And we all, I guess, we all use it somewhere, even if we know it or we don't know it, but in somewhere we are all now living in the century of where we use AI everywhere. It's extremely good in producing plausible output, is great for coding, and it's also great for automation stuff. So one of the big questions I have is if you're using AI as an assistant to help us, like a digital colleague, which I can go into chat and ask questions, or if you use it as an authority, and this is kind of a guideline also for this talk. And if we talk about that, I would like to move on and talk about learning, so how we learn things. So when we talk about learning things, and most of you, I assume, learn things like we broke it, we fixed them, we asked for help, we tried again. So it was like a recurrent process working with things. Even in administration or development, we learned through trying the same thing again and fixing our issues. So it was never efficient. So really, I think the things you learn, you can do very good. Even if in computer, or if you're good in music, or in sports, or whatever you can really good, it was always hard. You had to train, you have to practice a lot, but this is how you learn and bring things into your brain. So it could be slow, it is frustrating, and it also, of course, is a repetitive task to do the same things again and again. So what learning means also, that learning needs, in some way, needs friction, because things don't work, and explanation is unclear why it's not working, and also mistakes are visible. And failure as well was feedback. So if you did coding something, especially if you talk about our industry and technology, if system fails, if something is not working, you learned, you improve, and during that, you understand more and more, and you grew in your capability of doing the task you were into. What is really important is that we all have different, we learn different, but all over, and this is like this learning pyramid, if you've heard about this, and there's a source, but I learned that there are a lot of different models of this learning pyramid. But fundamentally, it's, if we read something, we are really not good in processing it, in keeping it in our mind, and understanding and develop a deep understanding of a specific topic. So it's more if we have like a practical work with something. And the best is if we teach something to others, it's the best way to learn. So if we discuss it, if we talk about it, if we try it, and if we do some things with our hands, it's the best way to learn. So just reading something is pretty bad. So I read this and I really liked it. It's not a bug, it's a teacher. It's something which is, I think, a really good thing for our industry. So most of the time we broke something, we again, at least we learn something how we can prevent it the next time. So how can AI help us with learning things? So one thing is, it's super good in recognizing something. So patterns, especially if you have like a big stack trace, put this into a ChatGPT or your favorite LLM. And AI is really, really good in pointing you in the right direction where something is the root cause, what could happen, and so on. So it's also really good, and I said that before, producing a good output. So helping you creating some things, summarizing existing knowledge, so putting things together, even if it's like text or code, like giving you an understanding of an existing code base, and giving you just a good starting point for something. On the other hand, AI is not creating a mental model about things, because this is not the way it works. It works about relationship. At the end, it's a mathematical model about words which are related to each other, and it does not create a mental model about learning stuff. It does not understand, if understanding is the right word, causality, and it even does not learn from the failure. Of course, it learns on your journey, because you have like an input, or you have your context, and you have the history in the conversation with your AI, but in general, it's not about learning from the failure during your progress. And so you will say, okay, but we have Stack Overflow before. So we did this already for many years. We Googled for some code snippet, pasted in our IDE, and if we were lucky enough, it worked. That's true, but this is done. It means it is clear that Stack Overflow is done, but it's brutal if you look at the numbers. And this is like, the last data is from January this year, so pretty much no one is using this anymore. And even it was like, a lot of people spent 90% of the day in Stack Overflow, and copy and pasting some source code until they get a final result. Not guilty 100%, but I did it as well. And sometimes it worked. So even before we used all these AI stuff, we tried to make it easy for us to produce an output. We outsourced learning and tried to copy something from somewhere else, but the AI made it super frictionless. So we get a result. We don't have to understand it immediately, what is going to be produced. We just copy it over, we execute it, it works fine. And the learning curve is totally different. So the new way, if you name it this way, of learning things is you prompt something, you learn how to prompt, you get the output, it works, done, you reprompt, you add something, you go in this endless loop until you get a result. Even if you work like perhaps the old AI way and just use ChatGPT and copy the code all the time, or now you use Claude or use RuCode or what all the tools out there to directly work with your code base. But at the end, you're just like improving with the AI working on your code. So the AI loop result is sometimes it works, Nobody knows why it's not true, I assume, but probably as a tuner you don't know why. And nobody can explain it. Totally depends, of course, on the complexity. So the consequences are that it's pretty much not a learning system. It's more or less a delivery system. So you work it, you produce code, like the excellent talk before, and of course you learn something, even you need to have all the knowledge to create the right prompt that the AI creates an application for you. But at the end you hope that it delivers something, but I doubt that you really learn it to really adapt and build on this. So, and this is also the heart of my talk, that delivery and delivery of code doesn't create a senior. So it doesn't create a person who is able to tell an AI what application you need. So the impact on the learning path we see is now, we are quietly removing away the path from the junior to the senior. The juniors get answers, so you give your answer, you give your question in, you get something out. Depending on the complexity, you understand it or not, but it's working, you get a working solution. But we really don't get the context between all this. And this can also have an impact on the career path, right? Because we have, we're not heading in a jobless future in this way, but it's harder to enter the industry because less companies, institutions are going to be willing to invest into juniors because simple tasks could be done easily with AI and pretty much also cheaper than AI. But how can young people and new people in this industry learn if the simple things are going to be automated away, if that makes sense for you? I think that that's challenging. So when AI replaces the junior work in some way, it also replaces the way in learning stuff we need. And especially we at the CfgMgmtCamp, we love all this. We love automation, especially when it works. We try to want to do it. It's on us because we love technology, but we are not so good in figuring out that we automate us out of the game in some way. So what is the impact on the job market? And that's pretty much an assumption, of course. Also, you see some signals right now. I'm pretty sure that we all have to get along with AI. So it's not something you say, it's not in the game. Perhaps if you retire in 2 years, you can say, I don't care anymore. But anyone else has to deal with it. We have to learn it. And you can also see that a couple of years ago, like a typical role on the job market was like prompt engineer. If you all remember, you have seen that a couple of times, people looking for prompt engineering. This is done because it's an assumption that you know it. It's just like your daily thing, like doing a git pull, a push or commit, that you know in general what a prompt is and how we can improve it. So already this market in AI changed dramatically because some roles are expected that everybody has that knowledge. So we have to get along with it. I guess otherwise 30% of our industry will lose their job in the next 5 years. Personally, I'm pretty sure that 30% of our industry will lose their job anyway, even if you get along with AI or not. And it's going to happen already. Means I will not count on enterprises like firing 2,000 people because it's always different. The market was overheated. And in some way, I would say like 4 years ago, even as a developer who were barely able to write 50 lines of code, you were able to get 50,000 euros a year, which is not, it's not good. It's also wrong. But the market enabled this. But I think we have a high impact on this in the job world in the next years. And it will be easy to remove a lot of fundamental work. So I'm pretty sure that this is going to happen. I live in Germany. We see an increased unemployment rate in all industries. Now we have an unemployment in 6.2% in Germany, which like 15 years ago we had 4% and everybody was crying a river that we have 4% unemployment rate. Now the reality is that we have perhaps 9% unemployment rate, and also this is not related to AI. Even like car manufacturing doesn't work so good at the moment. But I think we see that in all different industries that we are going to see a big impact in the job market. And there is just a shithole of jobs you can automate away with AI, and also a lot of tech jobs can be automated away very easily. So my advice would be learn to design and architect, because this is a role which is required in 5 years anyway. You need someone who is able to describe what you need, like by design pattern, all these things, but you will not need anyone in 5 years from now to write code, to implement a function you designed, or implement a method, or implement a button on a website. This is not a skill you need in 5 years from now. So what you need and what you will need in the future, you will always need someone who does the work with his two hands. Perhaps not always, let's talk in 10 years again, but that is something, a qualification which will last, and also someone who is able to describe the needs and requirements of an application, of a system. That is something, a skill set, who will gonna be staying the next time. So what is the junior and senior problem? So fewer junior roles, for sure, they already are. So we have a lot of apprenticeship in our company, and it is absolutely no statistics. So don't get me wrong, this is nothing you can build science on or build a talk on, but on average, we're like a 100 people company, and on average, we get about 6-7 job applications every day. Right now, we get 35 job applications every day. So this is super hard to get a job for an apprenticeship, and more companies don't hire young people to learn this stuff, because it's way easier to ask ChatGPT and Claude to write some script. So we will see a big change, I guess, in the career path of young people, definitely. So the expectations will be way higher early on. So if you can do fundamental basic work with an artificial intelligence, you have a high expectation for the people. So seniors, architects, and this is a question I don't have an answer for, which are able to design and describe what the application need look like, that they need security, communication, database, and all that stuff, they become rare. And also the salary polarizing on them will be, of course, a good architect will be able to make a good amount of money, even in the next years, because we will need this role. But it's definitely good for everyone. So we have to make sure that we don't optimize ourselves into shortage, because we don't have new young people taking over the design and strategic and design part for the AI. I think in 5 to 6 years, nobody will hire a junior if they don't have to. Everyone will fight for the seniors available on the market. I assume that will happen. And perhaps then people figure out, damn it, I'm not able to get a good senior on the market, and they try to hire new people again and train them. But this will be super hard, because a lot of these paths are cut off. So I think everyone will desperately looking for senior people. And then we have this expertise gap between the juniors and seniors, that we have a big differentiation between people could potentially make a lot of money and people who are really get hard to make a good amount of money, because it's easy to automate it away, but not in a healthy way, of course. So it's good for you if you're a senior already, or perhaps you have like 10, 15 years in the industry and have all this understanding about architecture and design. It could be good, I guess, for the system, for the society, probably not so much. So I assume, just an assumption, it resumes in a small group of high-paid expertise, and a large group of people will stuck in a path forward that they don't know how they can reach the next step. And this is not great for the society as well. So I also think, and this is my only slide about talking the bigger topic of this, I think this is not just a technical problem and a tech industry problem. It's just like everywhere where we replace the learning, I think this will happen. If we cut off a path for young people and new people to become a senior, we will go into the same problem. And we trade in understanding for convenience, resilience for efficiency, and the growth for optimization. So what about open source in this? So first of all, I would say open source is not primarily about code. It's a lot about the process, about visibility of seeing how things are done. Because when I started my career, it often was like, if you've open source, it's everything open. If you have a bug and you don't find anyone to fix it, just fix it on your own. But if you have a Samba problem, can you really fix that Samba code? Probably not. But you have the transparency. Perhaps someone out there can help you. So it's about the process of coming to a result. It's about the visibility. and it's about the shared context that different people working on the same stuff. It's a learning system, in my opinion, that people with open source can learn things. We had the discussion earlier today. You can come into a project, even just like contributing with documentation, which will also be a hard field in the future, writing documentation for sure. But you have a chance to participate in the process because it's public, the code is visible, and also that the decisions are made public and are going to be discussed. So I would say that open source is good for producing seniors. Open source is good for someone as a learning path to see what's going on, to get more confident in contributing, get more confident learning publicly what other people do, and contributing and growing in a project, in a community, and be part of it. Because the reviews create a context, you have disagreement, build the understanding, because you make up a pull request and someone comes back and they, I don't like it because ABCD, you have a conversation on this. And I think this is a big differentiation between AI and open source, if you in some way can compare that AI gives the answers to something and open source gives you arguments, it gives discussion in the community. And another thing is that an open source and an open collaboration environment doesn't hide the uncertainty with the AI, of course, does, because this is what it's built for. And I think that perhaps the first two doesn't sound like an advantage if I see it right. So the advantage, of course, is slower and messier. Perhaps you can see it as a disadvantage, but there's a chance in it, right? Because the mistakes are visible, discussions are public, and you had to expect the people to help you. And also, I think we need to be a little bit more resilient. I think the comfort made a lot of us, not all of you here, because I cannot speak for everyone, but I guess the comfort we had made us fragile in some point of view. We need to be more robust, even to stand an argument as an industry and also as a society. We have to be able and to learn to deal with things we don't like. And I think in some ways we forgot about this, that perhaps not everything we see we have to be confronted with. We like this, but this is just a part that we have to deal with this. And I guess open source is a way to do this. Open source is a way to build resilience, because disagreement is normal, it's part of the deal. Friction is expected, not everything works and not everybody likes what you do and what you contribute. The learning happens in public. And sometimes life is just hard. Sometimes it's not fair, but you have to, and we have to learn to deal with it, and not only getting the easy answers to grow as a person, to grow in the knowledge, and also to grow in the career path. So it doesn't remove the friction, it helps us to handle and learn it. And I think this is where open source is really good in. But to see what this brings an influence for us is the expectation management we have. So the expectation management, dealing with all this, is very important to the output, because the tools we use to do our daily work, this is part of the behavior. If we have misaligned expectations, we cause damage perhaps, or we're not able to reach our goals. So what we expect, coming back to the AI, what we expect AI to do. So right now we say we would like to have a super fast solution. It has to be cheap, it has to be confident, and it has to be correct. It should self-work. And I think we should have probably a different expectation. So we need an assistant where we can work on, not seeing AI as a tool, so seeing AI as just a way to learn together. See AI as a partner, and see AI as a sparring partner, as a discussion partner, I think is a good way to learn with it. So reduce the friction, support the learning with AI, get explanations, and expose this uncertainty always. And so a good AI expectation management, in my opinion, is that it's absolutely not about using less. So again, this is not, the talk is not saying, don't use this, it's dangerous. We have to deal with it. It will come. There's no chance. And even also if you see it from the point of view of regulations and ethics and all the things which matters in AI, with every big enterprise right now tries to figure out how we can have data protection, what is with ethics, what is going on. means the world moves on. For sure, in 5 years, someone in a dark office in the European Parliament will write a declaration of how AI should be used in Europe, but the world moves on. Everybody is putting his data in, so we have to live with this as it is. And that's, in my opinion, super important. So use it as an assistant, not an authority. Just not create an output, not a delivery system. Use it as a learning system. And in some way, it's really, really good helping you. So how about on time? So what? Keep learning in public. That's something I would definitely say makes totally sense if you can do this. Review for context, not only for correctness, and also try to make your mistakes discussable. So definitely try to have an open learning, have an open culture in your community, in your environment, in your company. Try to make your AI stuff explanations. So try to learn and just not only create a working result. AI will get a lot of better. I cannot wait to see what's happened in 3 or 4 years. Even like all the conferences and all the stuff we're gonna be developed is crazy. So, but also we have a lot of this discussion about these AGIs, this artificial general intelligence. I see a lot of the work out there, a lot of the jobs out there, they even not require this today. So a lot of this can also change today, and the influence will gonna hit faster than probably an AGI will come, and we have that impact. So the real question to me is if we get like lazier or more responsible. Sometimes I'm afraid I already know the answer to that question, because we have a high chance to be lazy. But I think this will shape how we have to deal with the issues we're gonna see, because the usage and the impact on our industry is something we cannot prevent and will happen anyway. So the automation part is super easy. Growing people is really hard. Thank you very much. Thank you. I think Paul is still taking a shower. So are there any questions? Do I have time for questions? I don't know. But no one is standing here trying to give the next talk. Are there any questions? 50? 20 minutes. Can you repeat it again? Sorry.
I'm wondering if, as business is going to do what business is going to do. In open source, I think that you're right. I think that it doesn't grow people.
Yeah.
But if there's nobody that wants people,
Yeah.
then what?
It's a very good question. I don't know. I don't know. Because we as a company, or as a group of different companies, we always relate to young people coming in. And I personally, I never went to university because I was super bad at school, simple reason. So I did an apprenticeship, like the typical career path, learning as a junior. And I think it's super important, but I'm excited about a lot of things in AI, but this is really which scares me, because if we cut off these learning opportunities, and at the end, economy is just brutal, because at the end, the big enterprises is like, will it be beneficial for me to invest in young people, in new juniors? And I assume that in 2-3 years from now, probably much earlier, for most of the companies, it will just not be beneficial in investing in trainees, apprenticeship, however you name it, and I don't have an answer for this. And I think we are seeing this already. This is not something which is not in the far future, right? It's already beginning that people don't invest into junior roles. And even the job market changed a lot. I mean, you all in the tech industry, assume some of you face this for centuries, some perhaps for 2 or 3 years. But the job market changed so crazy in the last 3 years. And then we talk about the coder. It means talk about people working in marketing, people doing like texting, documentation. All these roles disappear. They will disappear. Perhaps now in your project, someone is responsible for the technical writer of creating documentation, but this role is done. It's done. It's never coming back for sure. I would bet like all I have, which is now 20 euros, this is not coming back. There will be no point in time where they say, oh no, we need someone who is manually writing our documentation again, and I don't have an answer for this. As the responsibility, if that is an answer to your question, for us as part of the society, I think we should work hard in how we can train new people stepping into a junior role and another level, right? Doing other things. Because what we did like 3 years ago, they started and they, I don't know, just wrote their first Perl plugin. And they took them like 3 days figuring out how all this Perl stuff works, or Python or whatever. And I think we need a different entry point for them. AI and all this stuff needs to be a tool set they learn very early on. Like we expect them that they can read an email and follow a meeting invitation, which is like the fundamental thing we need all at work in some way in a digital life. I think we need to set the foundation differently. But it will be tougher because the expectations will be also higher to juniors. But I guess the entry level has to change for juniors to become seniors more quickly. Nobody will be willing to invest like 5 years into people until they are in somewhere more matured and going to be a senior. So it has to be all faster, so the entry point has to be changed. There was another question, I don't know. Yeah.
In the long run, every organization has a responsibility to reduce the risk of system failure. And sometimes that's just as simple as somebody leaving their job, somebody getting extremely sick and being out, and that resiliency is gone. So there's a risk management factor to ensure that systems are stable and being able to have somebody to be able to step in. The question is down to how much low-level stuff needs to be understood in comparison to a future that we project where there's going to be more system architect, administrator, even if they're not going to be low-level stuff. So I agree that there is a responsibility on us as practitioners to relay that risk of system instability to
Yeah.
CTO or somebody else so that they can get the somebody as a secondary to ensure that the system has long-term viability.
I agree. I think what changes, what going to be changes also that perhaps like 1 or 2 years ago, because now really more and more people, I don't know who's seen like Adam Jacobs' talk, which was really cool as a keynote, that like 2 years ago a lot of people say, oh, this coding, and their code comes out which nobody can follow up, and it's all too complicated. And I guess we'll see a shift from that. The documentation, like the context, the prompting, the design pattern of an application will be the value of something. In your organization, there will be probably a GitHub or a Git repository with the design pattern of your application, and it's not so important if someone can read your application code because you just generate it from scratch. I think there will be, even if this is hard to hear for someone, like all the like software designs and clean code and all the things which matters now to developers, I think are unimportant in the future. The most important stuff is your design, your subscription, the baselines that you need testing, and everything which is important to your organization, that it's secure, encrypted. But the code itself, it's just like wasted. All the cannot generate, and then it's not so important if someone understands your code base, if you just regenerate it from scratch in an hour again. Then nobody cares how the code looks like. And I think this will change, that the change we had in infrastructure years ago, that we had the server with the name, and the server had his life cycle for 6 years, and at some point we put it out of the rack and we salute and say thank you for your service. This changed to have a high mutual infrastructure with containers, and everything is not important because we fire it away. I think the same will happen with code base. That code base will be just, if we need a new code base, we just generate it again. And the value will be in the definition of that code base and the design patterns of your application. I think we see the same with code, what we see with infrastructure like 5 to 10 years ago. Pretty much more 15 years ago, to be honest. let's say the argument, we maneuvered our industry into having all our IT infrastructure with the several market players. The internet, which has a decentral idea, pretty much is not anymore. A couple of companies own all the highways, all the IP addresses, everything. So try to be a data center provider. It's pretty much impossible. Even pretty much it also makes sense. I think it's all false. The technology problem is in some way, you are right, but we usually embrace all the new stuff. Means I'm fascinated, and I'm not against this technology, but this fascination is also something which just makes it easy to forget all the downsides. And means if I see where we moved ourselves with infrastructure, that pretty much the AWS, Azure, Oracle, Google, that's it. It means, of course, there's like OVN, and there's a couple of others. But at the end, this is it. If there's like the East Coast zone goes down, pretty much half of the internet is down. And we accepted it. We accepted it, and CEO of large enterprises accepted it. The German Bahn accepted it. Means it's a company owned by the government. They put all their stuff to AWS, and they don't pay any taxes. Perhaps I just doubt in my fellow friends in this industry. I gave a talk about 3 years ago, config management, about convenience is killing open standards. And we had the same discussion about, like, it was like more infrastructure and cloud. Means, I think, perhaps I'm totally wrong. My opinion is like 90% of the people, they don't care. Means people put all their life into ChatGPT, everything. The next generation is not using Google anymore, perhaps the AI mode. Anyways, they use ChatGPT for everything. They put in their medical results, all their pictures, their whole life. They use it as a friend, which is 24/7 available. Put every privacy they have, put in ChatGPT. I don't know, I don't want to make it super political, but anyway, of course a government here can look to the data. I don't want this. I don't want this to happen. But even people who said we need to have a more sovereign infrastructure stack now use all, and we had this before, like perhaps biased trained LLM models now for their stuff, and they don't care. For creating biased text, creating biased articles. I think people are lazy. We are super lazy, and we are super addicted to if something is convenient. And of course, it's super convenient, we get more lazy, but then even if we are too lazy to go out running, it's not that we eat less and run more, and I'm a good example, we buy a new fitness tracker to see how less we have run. And even we know, most of the persons who have a big belly know why they have a big belly. I do too. It's not a secret. I could do more, but no, I can need another sleeping app, or another tracker, or make pictures of my food and run it through AI, how many calories it has. And even if they are fries, I don't need to take the picture. But this is how we are super lazy, and forgive me, a lot of us are super dumb as well. And even a lot of in our industry are just, a lot of the developers out there, and please forgive me, are also not good. We have a lot of people in our industry because the hype of the last 10 years made it possible that all the enterprises hired whoever they could get on the market. And a lot of people are just not good. And perhaps it's brutal. I don't want to be rude, forgive me, but just very bad people made a shitload of money to someone who really worked a real job and was carrying someone from A to B, made a third of someone who was able to write 10 lines of code a day. That's reality. And that's also not good. And that's my positive takeaways, that we clear up this mess a little bit in the job market. At the end, we have to find new jobs for all these people. And they don't want to take care of the elderly, I guess, because here we need jobs. But this is also an imagination that all these people driving a taxi now, taking care of old people in the future, or all the Python juniors which don't have a job anymore, taking a social worker role, will not happen. But I have no answer to this problem. And I think it's really a big problem. In 5 years from now, it will be a big problem in our societies in the Western world. What do we do with all these people? We can have I think, a two-hour more discussion about this because I'm really getting hot in this. I feel it. Anyway, yeah. Yes, it's good for me, I guess, and good for all of us. Yeah. I have no good answer for this. I mean, one question is how long are you or your organization is willing to pay all these people? So perhaps it sounds to me that the clock is counting down. So what to do with these people? Even I think it's not the right strategy to hold them away from all this AI stuff, because again, I think it's just like fundamental, it's commodity. We have to adapt with this. Putting them together. Bring them together against you, like the old team thing. Like they should do something together, because I think that's a way better path of learning. Bring them together in a room, they should develop an idea, probably do it without AI. They're gonna hate each other, perhaps they hate you more, and this is the result you want, because then they're gonna be creative again. And creativity is also creativity is also hard for a lot of young people, because of all this social media. It's another topic. We have a second track tomorrow, 8 hours, no. But being creative is something we also lost in some way, because every time we have like 5 minutes of laziness, we pick our phone and watch some TikToks, Reels, Insta, all that. And not my opinion, it's clear that young people have a problem in coming into a creative process. And I think you have to force young people to come into a creative process if they're not able to do so. And I think definitely a better result than everyone is like working individual with a cloud account, I would assume. You're right. Means I'm in that as well. Means I have young kids, and when I bring them to bed, I watch like TikTok. The algorithm is super stupid. There's nothing there. It's just people jumping down, jumping up, riding on a cow. It's really, but I figured out after half a year that, just a short example, I watched like a John Oliver, which is like an American comedian. It's like a 20 minutes, YouTube is the episode. So after half a year, these 20 minutes were way too long for me. It's like I open up the YouTube, oh my God, 20 minutes, go back to TikTok. Yeah, we all have this, like the short amount of time we are able to focus on something is not only a problem with the kids. Of course, we all in this dopamine trap, absolutely. I mean, I think there are steps forward. More and more governments thinking about perhaps like permitting access to social media for young kids. And I think this is a great step. It means everybody who has kids at school perhaps knows the problem, how to tell them that they're not allowed to have a mobile phone, because everyone else is on WhatsApp. But I think that is a big step forward, governmental, like not permission to social media. One thing. And I think we're going here in a better direction because we ignored it way too long. Absolutely, I agree with you. Anyway, this is going to way out of control. Thank you very much. Have a great day. It was a pleasure. Thank you so much.
Андрей. Все.
All right, folks, we can get started. Last couple of sessions in the afternoon, of course, coming up. I'm delighted to be introducing Pavel Lavrenko. You good?
I don't know.
It's your other screen. It's an extended.
Yeah.
It's extended.
And I lost my mouse.
It's like way over here.
Which angle?
It's like here. Press Command F.
Okay.
and it'll probably-
And wait. I don't see a screen choosing interface. Let's play again. Boom. Not yet.
Displays.
Okay. Displays.
It's like extended.
Mirror.
Yeah, there you go. Pavel's talking about digital twins and infrastructure. It's an area that has been super interesting for us for quite a few years now. It's always great to see another person in the ecosystem, and he runs a company called Foliage.dev. Enjoy. Thank you.
Thank you for introducing me. Thank you everybody for coming. I see you guys survived lunchtime. I will hope that you will enjoy my speak. Definitely I'm trying to bring digital twin approach to our industry. Let me tell you a few words about myself. So I'm Paul. I'm founder and engineer at Foliage. I was doing supercomputing for 15 years, and supercomputer is the beast which comprises of components you're very well aware of servers, storage, network, compute, user applications, data, facility. But what differs supercomputers for decades is that it's like a Formula One bolide. It should run as fast as possible. And my responsibility was doing that, because making it very fast, you need to overcome the extreme level of complexity between different domains. So my responsibility was that inter-domain coordination and making tools for that. So I can say that I was doing tools for infrastructure modeling and mapping for my different teams to understand supercomputer thing. Now I see that digital twins came to IT. I mean corporate IT. I see other efforts I'm very interested in. And maybe my solution, my tool will be of interest. I was asked to do mostly demo, and I will try to do that, but I still want to give you some context. So what is a foliage? Foliage is a runtime to do modeling of your infrastructure, not in a single model. I doubt it's possible to have a single place of knowing everything, because we have very sealed domains, and that's okay. Your network engineer doesn't want to know about your infrastructure as code and so on and so on. So which domains we can mention? It may be your application, like your software bill of material. It may be your Kubernetes, it may be your on-premise data center, it may be whatever team manages. And we're trying to make it visible across domains. So you can say, like, well, we can take Visio, we can take Draw.io, and just draw and negotiate before we start, which is true, and we all do. But how actual is your drawings of your infrastructure? We wanted to have actual live current models which can somehow play together. And for that, we have foliage engine, which allows you to have place for mapping objects. Under the object, we mean whatever you want. It may be a server, it may be a data set, it may be your part of your network infrastructure. We want to know how those things are connected, because what we learned from supercomputing is that for managing complex stuff, you want to know not just about some facts, but you want to know how different things are interdependent, how one things affect other things. So we have a graph underneath, and the task of the user is to map its domain with all the expertise user has, and then foliage does the rest. So in the demo, we'll cover how those live maps works, how they run, how they share data, how it can be used for incident visualization, because what we found is that incident management, one of the biggest issues in debugging complex things, and because it's a computational graph itself, I want to show you some tricks. So let's go to the demo. Okay, here is a place for our models to join. It's empty, there's no models running. So I go and run the first one. It runs in Docker, with Docker Compose. It's a standalone application runtime with all the model ontology and connections to real world. Here, you see it's very simple. It's called application, and I can have another slice of it. Here it is. Actually, it's a Google online store with 12 blocks. Each node, each rectangle is an object in a graph. You see it has its UID and place in the graph. Of very simple type, we called it architecture block. It's a kind of your software bill of material. It's the payload why we run the whole infrastructure. Let's go back to the overall screen and add one more model. And boom. It's starting. Okay, here it is. So that time we're going to be very conservative. It runs in a real on-premise data center with real servers, real hardware. So old-fashioned. We see here disconnected model. I mean, we have two models, they're not connected. The second one comprises of server running some hypervisor and a batch of virtual machines. We read it from the infrastructure with adapters which streamed data to a NAT bus, our data intake. Now let's go and run a third one. But before I continue, I want to tell a few things about the interface. We learned that drawing abstract star-like graphs is really hard to use. So we came out with a very thin user interface which directly connects to a graph, subscribes to it, and as soon as something updates in a model, you instantly see it. And the way how we draw it, we have some rules to semantically stabilize mapping of the slice of the model to your screen, so you will find the same thing in the same place each time. So let's run the third one. Okay, here it is. Here's the biggest part. It's a Kubernetes. Okay. It's not very detailed. So we have Kubernetes cluster, Kubernetes node, pods, deployments, and replica sets. But it's detailed enough so you can see the whole infrastructure connected. You see there's links between objects. By the way, a few things about links from the graph. We came up with an idea so you can render them either like lines connecting your rectangles, your objects in a model, or either putting some objects inside other, like a superseding blocks. They're all links in the graph. You just render it differently based on how you want to model particular domain. That's nice, but like a very small thing. Let's do some magic. I'm gonna introduce some problem. I will significantly rate limit a network interface on hypervisor. So everything will be operational, but struggle, like I will drop 90% of packets. And you can understand that the final service won't be accessible. But nothing will detect it. I mean, maybe some observability dashboards will, but I want to see the whole picture. So first of all, I will simulate the problem. Okay, we introduced rate limiting. Oh, boom, you see it on the screen. We marked not just hypervisor, but everything which is affected. How have we done that? Here's a pod object, and we see that restart count attribute is not 0. As soon as our graph is, as I said, a computational graph, so it's not just knowledge graph of objects, but there are also small functions, lives and works in the neighborhood of your object, passing signals across links of your graph. So the idea is that topology of your system becomes a signal path of a control system. So that function detected the increment in restart count and sent signals over graph. So other functions on other objects, like virtual machines, hypervisors, which are downstream, which are upstream, and everything up to your services in your application, which are upstream, are selected. There is even a trick. I can select all affected nodes and leave only them. We are not trying to do platform engineering. We are not building the whole thing. We want to provide you with nice maps or widgets you can embed into your third-party incident management, monitoring, whatever. So you can pick it and embed whatever you want, which is kind of nice. Okay. Now let's recover from it. First of all, I will ask Kubernetes to connect another node to the cluster. You will see it here. Boom. Here's a new node. You instantly see it. And but still system is affected. Now I will do that. I will ask system to remove the failed node. That's how you manage your Kubernetes actually, yeah. You remove something which is not working good. And see how my model will change. It takes some time for everything to settle down, so I will show you some tricks in between. There's another slice of Kubernetes, and slice is a small JSON-like template where you define which objects, which links you want to keep in the view. And as soon as foliage makes a computational graph, there's a thing. Those objects of podded node have CPU limits and CPU requests, and we can summarize, aggregate the data over a graph and put it in another node. So no time series or observability platform is involved. You just can do that in foliage model itself. You saw that something updated, so it's dynamic. And if we return back to data center overview, you see Kubernetes model and application model is clean of errors, but still issue here, because what happened, you see that everything migrated to that frozen leopard node and recovered. So here's the foliage as a way, on the first step, it's a way to map your infrastructure from different domains. Okay. Let's go back to slides. So what is our goal? We believe that future is digital twins, or models, which will help us build continuous management of complex systems, not based on some discrete tools and silhouette tribe knowledge, but based on a complete understanding of what's going on. What do we have for that? First of all, we have decentralized graphs, which keeps knowledge of real objects like servers, services, network segments, whatever, or our abstract knowledge about the system. It can be policy, dependency, some requirement we want for the system to have. Those models should be loosely coupled, because there should be an owner or team who have expertise for domain knowledge, and we want each model to be able to evolve independently, not affecting each other. As I said, in foliage, graphs act as a signal paths. So those are asynchronous functions living around objects, exchanging signals, conform, and I believe that in future will have very complex orchestration role. And I believe that we do need LLM for solving that. That all forms a so-called functional graph, the technology core we see to build digital models in the future. And the first step for that technology is a single communicational space between us, humans, and agents to clearly understand what we are talking about, how we want our systems to change, and interact with each other. Many times at configuration management, I heard that we should stop pretending we can reduce complexity. This year, in the beginning, 2 talks also was about that. I believe that our infrastructure is under documented, unstructured, very multi-domain. We can make a single red button which can fix everything. And that we should find a way for different experts to bring their expertise, but not pretending that there can be a single team, like a platform engineering team, which will be responsible for everything. So I can say that we should embrace complexity and try to find a way how to build right tools. Foliage is open source. It's about graph models. It's a kind of a mixture between knowledge graphs and application platforms. This is our first step, and we really want to collaborate and find nice use cases. That's pretty much it. Thank you, guys. I'm really open for questions. Yeah.
But how does the data then goes into Foliage? I mean, do you have agents in each domain that do some kind of data collection, or
So
how these mappings?
okay, so honestly, there are 4 models running, and the first one, the data center one, is rather empty, having a root node, so other models can connect because it's decentralized. That's how UI worked. I was connected to a single model called data center. As for the data, we believe that each type of the object in our ontology should have a function to connect to a real world, like parts, your LS-heavy, or whatever you want, your AWS command. Possibly written by LLM. So the question was how the model is populated with data. Did I answer it? So how I think about it, first of all, I want to say that we need to invent new user experience in modern world. For me, it should be a mixture of mapping, giving you a landscape, and narrative, maybe in a way of text. I'm thinking about future foliage like Google Maps. So you can either go to mapgoogle.com, or you can embed it in your website showing for some visitor how to find an entrance. It depends on your scenario.
It's not just like a bitmap. It has metadata and routes and things. You can consume the result of foliage in a third-party application that will include like position
In a way, yeah. So think of it like you have a Grafana running, and you can take the widget and embed it into your system. But the Grafana itself runs somewhere. Sorry, the question was how it should be consumed by third parties.
So I got a question because this looks great if you have a small amount of containers and infrastructure. If you have something like 1,000 nodes and million of pods, it's going to be nightmare.
It's very naive to render 1,000 rectangles. So we are exploring that domain now. There are a few tricks because it should work like you have a slider which you can like move and adjust the level of details you want to see. And if it's collapsed, you see like saying, oh, there are a bunch of servers, like 1,000. Oh, and you can go inside.
The second question, this tool looks really great to see what was happening and how the elements were interacting. Any plans to, for example, to add a replay option, so we're able to see what happened from that point to another? That would be great to see step by step what was going on.
One of the challenges I see, so the question is, are we going to support like history of model evolution? The answer is yes. It's a very tricky thing. We have some experience. We store both previous step and current step, so we can have like a diff of the evolution for one step. The trick is to find a way how to do it with a timeline, like a time machine. Some more questions? Do you think that guys make sense? Cool. I really would love to try with some pilots, so we're really open to try.
I will look into the repos because we also have maybe for fault analysis what's going on. We would like to say visualization. Right now we have different ways of visualizing that, mainly for others in Prometheus in Grafana, so in a different way. But sometimes seeing it in that form as a map is very useful.
My vision is that we should have kind of two endpoints. For example, one for your incident management, so you can like map it to us, and another for end user to be able to open some landscape with some burst radius.
I think that the different views are very useful, so that depending on who you are in the whole organization, you're interested in different views, different databases with the applications.
Yeah, actually,
you can see the same problem with different points.
Yeah, my idea is that team on a Zoom call, when something happened, should open a map and not like a milliard of different dashboards and metrics. I believe that's it. Wow, thank you.
Some chocolate. Folks, just a couple of minutes until we change over.
Check, 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 check.
I can use this one. Sure.
visual tool in the space. I'm kidding. I'm kidding, because people used to tell me all the time, you're building a visual tool. It's not.
It's like
Yeah.
technologies underneath, you know.
Make sure and come for curry. Make sure and come for dinner, okay? No worries. You'll need that. You might need a little bit closer. Jake, it's on me.
Hello, hello.
Try that.
Hello, hello. Perfect.
Hi, folks. We can get started. With us this afternoon is Mauro and Jordan. They are officially, in my eyes, the winner of the best talk title of the entire competition. It is like one of the most fun talk titles I've ever heard in my entire life. And it's called Cloud Native at the Far Edge, running Kubernetes and AI on tractors. Okay? Fascinating. My father-in-law has a tractor. I definitely want to run Kubernetes on this tractor now, so thank you both. Enjoy.
Awesome. Thank you. Thanks everyone for being here. We really appreciate it. We know that it's already late in the day, you know, energy is going down. Probably a lot of you were also at FOSDEM, so we're going to try to make it as chill as possible to make it joyful for you and ourselves. So yeah, let's just get it started.
Yeah, definitely not the most typical. Is it working?
Yeah.
Definitely not the most typical talk. Hello? Hi? 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 Like that? Better? Okay, cool. Yeah, it's not the most typical talk, for sure. Let's start with why do we use AI on tractors and how does this help for a more sustainable agriculture? So it's estimated that 25% of crops globally don't end up in the market. The reasons are usually spoilage, labor shortage, or size and shape irregularities. To give you some context, in Belgium and Netherlands, the average farm is producing 10 million fruit per year, and 2.5 million of that doesn't make it to the market at competitive prices, and a big amount ends up in waste. Now, at Aurea Imaging, we are trying to reduce this waste and make a more sustainable orchard for the farmer and for the environment. And there are many ways to do that. I'm going to talk about our main application, which is called blossom thinning or precision thinning. And it's a quite common way for agronomists to deal with their yield. Basically, you spray a salty solution to the trees early on in the blossom season. That causes some flowers to dry. And then the tree puts its energy on the remaining flowers, causing less fruit to grow, but larger in size, more uniform, and often of better quality. Now, this is a bit of a process, a sneak peek of our process. Basically, is the reason why we do need to run AI on tractors. The grower is driving the tractor in the field, and then we use AI to detect blossom according to machine learning models. We create a map of all the trees with their blossom level. The grower, of course, validates this map, adjusts some thresholds, and then loads them up to their sprayer implement. And then they go about spraying in an autonomous way. And that's not only increases their yield of fruits that they can sell to the supermarket at the end of the year, but also decreases the amount of spraying, so they use less chemical. Now, to talk a bit about the product, it's called the Tree Scout. It's basically a set of camera sensors, an NVIDIA Jetson board. It's integrated with a tractor GPS for geolocating the blossom and the trees. And yeah, it's also connected to a universal terminal in the tractor cabin for the farmer to operate it. As you can see, it's doing real-time scanning. It's driving through the field, and it detects blossom in real time. Now, why do we need to do AI on the edge and on tractors? It's basically because we have a lot of image data to be processed in a short amount of time. It's very crucial that the grower runs the application in blossom season, which lasts a couple of weeks at maximum, to get the results they need. And yeah, we are basically very limited by bandwidth. So tractors don't have Wi-Fi on board yet. We have to rely on 4G and LTE networks. And that's the reason we take advantage of GPU-enabled devices like the NVIDIA board to do all the AI inference on the edge and do the heavy lifting there, and then send the more lightweight packages to the cloud for further processing. Yeah, of course, AI on the edge is quite a novel field. It's coming with its challenges, and that's what we're going to talk about. I'm Jordan. I am originally from Greece, working in the Netherlands for a company called Aurea Imaging as a software engineer. My focus is on edge and IoT solutions, and lately I've been working closely with Mauro and the Kairos team to bring Kairos into our project and integrate it with the Tree Scout. So I'm going to pass the floor to Mauro to talk about that.
Thanks, Jordan. Yeah, my name is Mauro. I'm originally from Guatemala, but I am local here in Ghent, so I'm very excited to see this event again and again coming back. I work as a staff engineer at SpectreCloud. We do manage Kubernetes pretty much everywhere, including the cloud heavily. I am a maintainer at Kairos, which we're going to talk a little bit more throughout the talk, but to give you an idea, is basically a framework that allows you to take your favorite Linux distribution and convert it into an image-based immutable system so that you do deployments similar to what we know today as over-the-air updates in this kind of systems. And I'm also a host at Cloud Native Belgium, or Cloud Native Brussels. You might also heard that name. And we're always looking for speakers, venues. So if you want to collaborate, please reach out to me or the two gentlemen there if you can lift your hands. So sorry for that. Let's continue with the talk. Like Jordan was saying, at the edge, there are many challenges. He was mentioning about using certain types of networks, which might be reduced bandwidth that you would have, for example, in a data center, right? And the problem with edge is that edge can be so many different places. It can be a farm, it can be a grocery store, it can be even a mini data center in a telco antenna or something like that. So it's hard to know what kind of problem you are going to face. It even happens that, for example, we have seen for companies in the grocery market industry that two different locations might mean very different kind of environments with different challenges. And of course, it will depend on what you need to have in that environment, whether it's high availability or not. But some of the biggest problems are your device is exposed. So someone who any person coming to a grocery store, for example, can now become an attacker of that system, right? Or in the case of networks, if you don't have at that moment LTE or 4G for the tractor, you cannot do an upgrade, right? Like that can be very problematic. But we can address or try to address many of those issues with a system like Kairos, with an image-based kind of system, through kind of like what I say, 3 pillars of what we try to tackle. The first one is we try to enhance security. How do we do this? We do this using image-based and immutable systems. If you have an immutable area of a system, it means that an attacker cannot go and simply install new software, for example. And obviously, there are always certain limits of what a person can do depending on how well they understand the system. I'm not trying to say here that it's completely impossible. What I'm trying to say is that you reduce the amount of attackers that can actually reach out to your system. We also offer a feature called Trusted Boot. What this does is measuring different parts of the system, like the kernel, the init RAMFS, and more, which ensures that only your operating systems boot in your devices, or otherwise they get bricked. And this, of course, is very useful if maybe the device might have some value, but the biggest value for you is that not all of a sudden you have an attacker that lives in one of your devices, right? Another aspect is no configuration drift. This comes again from the same principles, right? Because we have an immutable system, you cannot just go and run a tool like Ansible or anything like this and try to mutate that system. Instead, every time you're doing a deployment, that machine will be that same system until the next full upgrade. And the upgrade, it's either what we call an AB or atomic upgrade, where either the system is the new system, or if something fails, it falls back to the previous system. And last but not least, we have what we call, simplicity in maintenance, right? Like what we try to do there is that if you're at the edge, you might not be able to easily send engineers to fix any problem on that machine. So you need a very simplified user experience. In our case, basically, you have a booting menu where you choose which of the images you're going to be starting to run. So it's very, very simplified, where you can do upgrades, when you can do, let's roll back to the previous system, and no more than that.
Yeah, really, really cool features there. A really cool feature that integrates well with Kairos is Kubernetes. And it also happens to be how we base our edge architecture with the Tree Scout. To give you a bit of context there, it's the 3rd year that we are running the product. The first year was more of a beta release. The architecture was completely different. We had basically a single Python service running in a Docker container with 4 or 5 pseudo microservices based on Python's multiprocessing library. But that didn't play quite well. It didn't give us the control we needed. It didn't give us any orchestration at all. We couldn't have any insight into why bugs, to troubleshoot bugs, to locate them, to understand the state of the system. So we had basically some choices to make for a year later, where we had the next Blossom season. So the most traditional approach would be to follow ROS, Robot Operating System, which is coming with C++, Python as well nowadays. But the team didn't really have the expertise for that. We weren't really embedded engineers. The learning curve would be quite steep, and we needed a functional product within a year, and we estimated that would take for sure more. And then coincidentally, we stumbled upon SpectroCloud at KubeCon in Paris, and we learned about K3s, this lightweight distribution of Kubernetes that is used quite a lot on edge devices. And we said, let's give it a try. We basically split our code base into microservices properly. We made a proof of concept. We saw that it works well with our application. And yeah, we now have control. We have a way to identify bugs, the source of issues, and easily deploy to our single node cluster, basically, on the edge device. And also the 4th Blossom season, we are quite happy so far with that.
Very nice. Yeah, that's basically how they found out about Kairos and K3S through a presentation that SpectreCloud did at, I think, KubeCon Paris it was. It was specifically the one you see to the right. And what I want to mention here is when you want to adopt a certain technology, you also want to assess whether you're becoming a pioneer on that, right? Or if it's something that is stable within the industry. Well, part of what we believe is that Kubernetes has been for a while now a reality at the edge. You're not pioneering anymore if you're trying to do it. Obviously, it's maybe not one of the most stable things. You're still going to be learning in the process, but there are very good examples out there. These are two examples that we really like. I put them there especially because they are in the healthcare industry, which tends to have very high regulation, expectations, and more. And so when they found out, they considered it as an option and wanted to look deeper into what Kairos could do for them.
Yeah, and basically the last half a year, we've been implementing Kairos with our systems, and we've seen a lot of benefits. First of all, last year, our fleet of devices was about 25 devices deployed globally. This year, we have 50 devices expected for the Blossom season in spring, and towards the end of the year, more than 80. So our fleet is growing fast, and we needed a way to ensure that it's homogeneous. We also rely heavily on the NVIDIA ecosystem. We use all sorts of tools that they provide, like Jetpack, CUDA for the GPU interface. So we needed a sophisticated way that Kairos provided to do OS upgrades in place and over the air, of course. So basically, the main benefits for our company with implementing Kairos is basically that we don't really need to send engineers on site to do the OS upgrades. They don't have to connect their laptops with a USB cable and flash the device. We just do that, as Mauro mentioned, with the Atomic A to B upgrade remotely. And as our fleet grows globally, it's quite crucial for the operations of the company. And also the troubleshooting is much more reliable. As we don't have snowflakes, we are confident that all the devices have exactly the same packages and exactly the same network configurations, installer versions, kernels, everything is the same. So we can write reliable troubleshooting guides, and we don't have, as developers, to always be asked for third-line support. We can outsource that to our operations, and for issues that are well known, it works quite well so far. And of course, for the farmers, it's also quite beneficial, as we aim for a 20% reduction in fruit waste, as I told you. Of course, that's not so easy to measure, but it seems they are adopting the technology. They are spreading the word. The product is actually quite well known in the Netherlands mostly, Belgium, Germany, but we are expanding, and yeah, they seem quite happy for it, and we couldn't make it work without daring to try novel technologies in the open source community, like Kairos, like K3S, like cloud native on the edge, basically.
Obviously, there are also benefits for Kairos as an open source project. We are 100% open source. There are no certain features that you get extra if you pay or anything like that. We're a limited number of people as maintainers working on it. So that means, of course, that in terms of time and in terms of resources, we don't have everything that we would like to have. As an example is the different devices like the NVIDIA Orin NX that Aurea is utilizing. We don't have one of those to test Kairos. So of course, it was a collaboration where we were helping to guide Aurea how to make the board work. And the big benefit that we got as an open source project is that they contributed all that knowledge back into the code so that the next person coming with that kind of device is basically one line of configuration just to have it Kairos running in that system. The second aspect that is quite good for us as an open source project is the feedback, because you might not believe it, but many times you have no clue who is using your device, your open source project, until something is broken. But sometimes it's also nice to hear when things are not broken, and to be able to dialogue and say like, hey, why does this work this way, and have this open communication is also beneficial for us to understand maybe people are not continuing after a certain step because it's not clear enough for them or something like that. And last but not least, it improves our collaboration mechanism. So now, after this working together, we have also put in place proper rules how to bring collaborators, new maintainers, and other things, because we have seen at least 1 or 2 cases of how this kind of processes work. And overall, I think it simply makes a project, an open source project, more maintainable, so that the governance is more trustworthy, more open, and overall that it's working on real things from real life, right? Like, I cannot explain how exciting it is to know that your code is running on a tractor. It is pretty cool. I am.
Yeah, and I think the best feedback is basically to see your product running in production. That's the outcome, basically, after doing all the blossom detections and loading the map to their sprayer. The growers can go about spraying autonomously, automatically in this way, basically, on a tree-level precision instead of just spraying everything or with labor-intensive ways.
Awesome. Well, while you watch this on the background, is there any question?
What's the overhead of running this in a tractor?
What's the overhead of running this on a tractor?
Well, we just replaced the operating system with Kairos, and we built everything on top of that.
So it's like,
yeah, exactly.
Anyone else? Yes? The question is about whether you guys had to, think about energy consumption.
It didn't really change much, does it?
Wait, maybe use this, because I think questions are going to be more for Jordan.
Sure. Better? Yeah. So implementing Kairos to our system didn't really change much in terms of that, but yeah, basically the tree scout is connected to the tractor's battery, so it is dependent on that. And our main mode of shutdown is hard power cut. So that was the reason we had to switch to Kubernetes, and we wanted a more sophisticated system. We needed the control plane, the scheduler, to be able to spin up the pods when things go like, yeah. Yep. Sorry? It's an NVIDIA Jetson or in an X board. Alongside sub peripherals and like modems for the 4G communication, but it's basically that.
Anybody else? Have you had a chance to drive a tractor?
I did, yeah. It's part of the onboarding of the team. Yes, we do.
Awesome. Well, thank you very much. Oh, sorry.
Yeah.
What's the size of the whole deployment that you run on the tractor? How many gigabytes take the system?
The image, it's a bit, I think currently we are at 30 or something like that, but gigabytes.
It will really depend on the application
Yeah,
that
and
it is running.
it's basically a Docker file, and you define everything in a Docker file. Mm-hmm. So there are some, I think Mauro, you know better, but we are using some partitions that you can write indeed, but the main partition is read only.
That's correct. There's just an area of the system that is immutable where we think you're not going to change the operating system itself, but there's enough space for writing data for the applications. Yeah, that's correct. Yeah. So I think we need to give time for the next person, but we will be just outside if there are any questions. Thank you very much.
Guys, online
thank you very much. Appreciate it. Thank you very much.
No problem. Job for me with that.
Love to help out.
I'm going to give you yours now so that I don't forget that same. Thank you so much.
Thank you.
I appreciate it. No, can't fucking take me anywhere. I have one job. One job.
Oh wait, let me.
Beautiful little language. You should check it out. B-E-N-O. A Microsoft talk to finish the day.
Yeah, let's talk about hyperscalers, right? Switch. So do you know how late the beer starts?
Sorry?
How late does the beer start? The
After this talk, basically, everyone goes to.
Yeah, so I'm gonna
You're
run through. Yeah.
You're between these people and beer is what you are. Okay, lovely people, you ready?
I am.
Good. Okay, last talk of the day. Okay, Daniel is here to talk about Azure Service Operators. Remember, be nice. He understands that he's between you and alcohol, and he's very aware of that fact, and between himself and alcohol. Thank you so much.
Thank you. So for the last talk of the day, let's talk about hyperscalers, right? So I'm gonna explain to you what AKS is. I think you know it, but still, let's start out with that. What an operator is, if you don't know. Then talk about the service operator, how it works technically, and what the difference is between Terraform, Tofu, Bicep, and the Azure Service Operator, and how you can do this yourself. And I'm going to show you the demo at the end. So to get started, my name is Daniel Paulus, and I'm a cloud native consultant for SplitBrain. We do data center tech and link that with cloud tech, Azure local basically. You can extend Azure to your own premises. So why would you even look into the Azure Service Operator, right? We all know we have Terraform. We have other stuff that we can use to do this. But when I came to a client that had a lot of Kubernetes developers, they were all like, why do I have to learn this new language? Just let me write YAML, right? And what the service operator basically does is it makes a Azure resource a Kubernetes
resource. No state issues to manage with Terraform. But what then is AKS? It's Microsoft's version of Kubernetes. It's opinionated. You get a bunch of tools out of the box. You don't have to manage. It's cloud-based. The fun fact is that if you game online, it probably runs on AKS. If you need to use Office 365, it's definitely running on AKS. This is all public information. You can find it throughout the internet. And you don't have to manage the control planes. It integrates with Azure AD. You get networking and monitoring out of the box. And you can enable things as add-in, which are basically open source components that are also managed by the deployment you do in Microsoft. So if you use Argo CD, you can add it on your AKS cluster and it gets updated with a AKS upgrade. Super handy to make that somebody else's concern. So what's an operator? It's basically a specialist that knows how you can do stuff. It ensures that whatever you deploy gets checked for state, gets updated if the state is different. It makes sure that you get to a consistent environment, and it makes everything declarable in YAML. I know that CfgMgmtCamp is tomorrow, so this is just a teaser, but we all do YAML nowadays. And if we then zoom into the Azure Service Operator, it's the specialist that understands how Azure resources work. So in Azure, we have the concept of a key vault and a storage account. So now I can deploy a resource that basically acts as a storage account and gets translated into Microsoft's ARM language and then deployed to the right API endpoint. It uses workload identity, so we don't have to deal with secrets, which is basically a win. And you might have heard about Crossplane. It's a CNCF project, and this technology is basically built on top of that. So what it's doing, right? It gives us extra CRDs in our cluster. Let's say storage.azure.com. So I can now create a object that acts as a storage account. And it's written in Go. So if you understand that language, they're still looking for maintainers. It's open source project, so you can actually contribute. The controller makes sure that everything that it does, it translated into the desired state ARM API calls. The benefit that this gives you is that from day zero, you have all the opportunities that the API gives you. There's no need, like with Terraform, to wait for a specific feature to go live and for someone to then contribute that feature into the operator. When you deploy the object to Kubernetes, the operator makes sure that the resource is made or modified in Azure. And even if you destroy the object in Azure itself, it makes sure that the state in the cluster is updated as well. So it has write back. So what's the difference? Yeah, you can see it. It's truly YAML based, right? So if we then look to Terraform or to Tofu, the spec is, for me, it's easier to read, but There's a whole lot of people who prefer the Terraform syntax. I like the YAML one. But if you then look into Bicep, which is Microsoft version of Terraform, you see that the YAML language actually makes more sense reading than the Bicep one. This is all compiled into ARM, and ARM is XML. So thankfully, we don't have to look at the ARM language anymore. So how would you use this, right? I came across the Azure Service Operator when I came into a large enterprise where multiple teams were building multiple versions of different Terraform modules. There was no overlinking practice going on. And the goal was to make teams more efficient. They already did Kubernetes. So they all had their own namespaces in Kubernetes already. And within those namespaces, we then created all the secrets that they needed in order to create Azure resources. So this was done on a per team, per namespace basis. And the RBAC rules only entitled them to the resources that they were allow listed to create. Because when you deploy the Azure Service Operator and you deploy all the resources that you can do, your Kubernetes cluster will fail. It's too much resources. It can't keep up. So you have to be agile in what you allow, start lean, and then add services as they're needed. You probably don't need everything. It interacts with Argo CD or Flux, if that's your flavor. And what we saw happening is that everything was put in an app of apps. Everything was managed in a controllable way. And if your app is dependent on a Redis instance in the cloud, it simply waits till that Redis instance is created, and then it continues with the rest of your flow. It's super handy if you want to do temporary environments, because as soon as your PR is merged, we can simply kill everything that was part of your PR and destroy everything. There are definitely pain points. The biggest one is that the Azure Service Operator does not do validation before it's trying to deploy a resource. So especially for, let's say, a storage account, you cannot use a dash inside of the name. It has to be one word. Things like that. Or if you want to deploy a container registry, you're only allowed to use letters, stuff like that. It's not checking, so it can fail. You have to reconcile a lot and check and see if it works. Let's go back. The describe is really handy if you want to see the errors because it writes back, so it keeps you in the loop. Especially when you use Argo CD and you want to deploy an entirely new environment, Azure rate limits hurt. So it can take a while before your entire environment is up. And drift, it sees drift, but if it tries to correct it, it can definitely crash. and I've seen it happen. And then your operator gets into a crash back loop, and then nothing works anymore. So it's definitely something to keep an eye on. Let's just show you how it works, because that's way cooler than me talking. Duplicate. Yes, this works. Okay. So this is how it looks like when you want to deploy a storage account with a name without dashes. And one of the things you might see in this spec is that we have to provide an owner. The owner is basically the resource group where you want to deploy it to. Which is the most simple spec you've ever seen, I think. It's just to deploy a resource group to Azure. So what we're going to do is I'm going to show you the operator log. Mark. And I'm going to deploy kubectl, the resource group. While that is on its way, you see that it sees the deployment, it starts to act on it right away, and it sends it to Azure to the specific endpoint. And if we now check in Azure, we now have the sample resource group. So you see it's really fast. This is a really fast resource, so that's helping. Let's try the storage account. You also see which credential it's picking up. So as soon as that fails or whatever, or you have multiple teams with multiple secrets, you also see which you have to fix if authentication fails. That's super helpful. I'm expecting a resource group to, a storage account to be made in this resource group. Done with reconcile. And there it is. So we now have this resource group and the storage account made. So one of the things you can do is a storage account also has something called a access token for the storage account. So one of the things you can do is you can add extra properties to this object, but you could also write back a secret which contains your storage key. To show you an example of that one, I have deployed a managed Redis application because a Redis has something that's called a access key. So here you see that you can tell the operator, like, hey, from this Azure resource, make a secret within Kubernetes namespace that contains the host name and the access key, so that as soon as I want to do a deployment of an application, I can tell the application the Redis password you can find in this secret. So if we then go to Azure, you see that we have the Redis cache here, which is basically a basic instance, no secret sauce. The only thing is I can deploy this live because it takes like 20 minutes for this thing to be available. And I also deployed the app already, so let's go here, forward. And you basically now see that it's interacting with that cloud instance through the secret. So the secret is mounted in the pod knows where to go, and we're now having a Redis instance in the cloud. Because the only thing that runs in this namespace is the front end. It only needs Cert Manager to work because it interfaces with Azure, which they want to do on a secure channel. I tried to deploy Open Web UI and interact with AI because today we heard again a lot about AI. However, I didn't get that fixed. I can, however, show you how the resources then would look like. That's the app. So how I would do this, I would create a namespace and then create a resource group in Azure. And I need ChatGPT in order to do this. So I would deploy the cognitive services within Azure, write back a secret with all the endpoints and the keys. Also deploy a Postgres database. The downside here is that you have to create the secret yourself for the admin account. So here you'll see that I reference a pre-made secret that then is used to deploy the Postgres database. And if we check in Azure, you will see that it's actually did that. It is here, it works. What I just ran out of time to also deploy the Open Web UI app itself. So I basically flew through it, which is kind of nice, because there's beer waiting at the end of the hallway. Any questions about the Azure Service Operator? I think it's still a thing, yes. Yeah. And so the benefit is the write back and the state adoption, right? But that's also the downfall. So if you have multiple systems that can create resources, that becomes dangerous. Yes, I'd say to the teams, pick one and stick with it. So if you are already doing Terraform or Tofu, stay there. And if you don't want to learn that language, this might be something that you can adopt. What I've also seen is not everything is in the Azure Service Operator yet. So that's also sometimes annoying. We deploy the operator as the platform team. Yeah. So there indeed is an index which they can see. There's an internal a Git repo which contains examples, and we tell the teams also, hey, this is the Azure Service the Azure Service Operator. It's open source. If you miss something, see if you can contribute back. But most of the teams are like, yeah, it does everything I need, right? I need a database. It creates a database. I need Redis. It can do that, stuff like that. I need a storage account. We haven't run into anything yet that it can't do. Not totally true, because it can do Azure Foundry yet. And so if you want to do AI stuff, it does AI, but not Foundry. And because of all the rebrands going on with Microsoft, of course, then you might miss something or misinterpret something wrong, and then you think it's not there, but it's just the old name, and then stuff like that is happening, yes. Anything else? Let's go for beer.
I actually did not expect anyone in the